Hey my dear warriors, welcome to the marathon session of ray optics. This chapter is very important for not just your board examinations but also the NEET examination. Like I mentioned on the thumbnail also, that expect 3 questions related to ray optics, optical instruments, prisms, dispersion, lenses, reflection, all these things. So expect 12 marks in your NEET examination coming from these chapters. And this also means that once you do this, you will gain confidence and you will have an edge over others. So in this marathon one-shot session, I'm going to complete ray optics. Tomorrow there will be a separate class. If you're watching this recorded, you can find it in the playlist for optical instruments. Alright, my name is Shreyas, I'm the physics master teacher. And before we begin, make sure you smash the like button and also hit the subscribe button. So nice to see all of you out here. Vanakkam. Hello, good evening, happy evening, thank you so much Harni, VL Party, hello Mahalakshmi, A Singh, Niveda, Madhumista, thank you so much guys for all the lovely wishes and welcome. Hello Sandhya, hello Pooja, hello Joel, hello Kirti, hello Tarika, hello Aarti, hello A Singh, good evening bacha log. So I hope you guys are all set, ready to go, and I'm going to maintain the flow of NCERT, so the manner in which NCERT covers the entire topic. Almost the similar flow I'm going to maintain, so that way your NCERT is also covered, board exam preparation is also done, and NEET exam preparation is also done. So everything done in today's session. So I hope you have smashed the like button and I hope you guys are subscribed to the channel, because or else you'll miss the classes which I'm going to conduct in the days to come. So let's start with reflection. Now whenever you have a shiny surface, whenever you have a shiny polished surface, the light which falls onto it or the radiation which falls onto it bounces off, which is called as reflection. And these reflected rays with the incident rays have certain principles or laws which they obey. There are many applications of reflection if you think about it, like the daily mirror which you see. Alright, you see your face in the mirror, that is a mirror, that is a reflection based phenomena. Your mirrors which are there in the car or your vehicle, the side view mirror, rear view mirror, again an example. The dentist uses a mirror. It's a curved mirror, but yes, it's a reflecting phenomena which is used over there. Also, you will see in parking lots there are mirror placed. When you take a spoon, alright, and you see that the surface is curved, you will see your image in a very different way. Or you might have visited Hall of Mirrors. You might have also used a kaleidoscope. You might have also heard of submarines using the concept of periscope to see objects above the surface of water. So there are many such applications of reflection or mirrors. Is that okay? Yes, Asing, current electricity after this. We'll also have electrostatics, hopefully. Okay, the marathon, I don't know, bacha, Susanda, it will be more than 2 hours for sure, maybe somewhere close to 3 hours. Let's see how it goes. Now, what are the important laws of reflection? We'll come to that, but before going ahead, remember why the chapter is called ray optics is because when light originates, where does light originate from? From a source. Like you might have seen a source of light, a bulb, tube light, lamp, anything. It travels from that source to the destination in straight lines, in the form of rays. Rays are straight lines. So that's why the chapter name is also called as ray optics, sometimes also called as geometrical optics, because a lot of geometry is involved, because when the light goes from one medium to other medium, or it changes, bounces back because of reflection, you will see some angles are involved, maybe some triangles are formed, maybe there are some parallel lines. So that's why you will use some geometrical properties. So that's why also it is called as geometrical optics. Starting with the 2 simple laws of reflection. The first law is nothing but, all the incident, this is the ray which is falling, that is called as the incident. The ray which bounces back is called as reflected. And the third one, it's not a ray, it's a construction. So the perpendicular drawn to the mirror surface is called as normal. The incident, the reflected, and the perpendicular drawn are all in the same plane. Do you see this red dotted line? This is a plane showing, or containing incident, normal, and the reflected ray. That is the first principle. The second one is basically the angle which the incident ray which makes with the normal is called as angle of incidence. The angle which the reflected ray makes with the normal is called as angle of reflection. Both these angles are equal to each other. If I give a small angle, it will be reflected at a small angle. If I give a large angle, it will be reflected at a large angle. So angle of incidence and reflection are always measured with the normal. Everybody with me? Yes, the ray always shows the direction of propagation. Yes, this one shot is enough for NEET preparation. Definitely, Deepak. Okay, hello everyone. Some Chinese person is also there. At least the name is in Chinese. I hope you convert it into something readable. Okay, so we have a question for all of you. Let's see how many of you can answer this. A wave or a pulse is reflected from the surface of a denser medium back into the rarer medium. If the ray makes an angle of pi by 3 radians, actually radians word is missing, with the reflecting surface, then the angle of reflection is, if the incident ray, I think the word incident is also missing over here. Let me just add these terms. If the incident ray makes an angle of pi by 3 radians with the reflecting surface, then the angle of reflection is how much? Come on, my warriors, everybody spam. I want your attendance, I want your strength to be seen in the chat box. Don't remain silent, don't feel shy, don't be hesitant. Even if you give the wrong answer, it's perfectly okay. Nobody is going to judge you. And I want to see your participation, or else I won't get the motivation to conduct these marathons. I'm standing over here for all of you for so many hours just because you are going to learn from me. So make sure you post all your answers. Okay, most of you. Sudarshan, Pooja, Suchimama saying B no, Suchimama saying 30 degrees, which is pi by 6. Others are saying B, which is pi by 3 radians. Alright. Anush saying option C. Most of you are saying option B. I think most of you are wrong. The correct answer is C. That's the reason why I told it is very important for you to participate. So if you don't participate, you will not have fun. Because most of you made a mistake now. Now your eyes are wide open. Yes or no? You're like, what the hell happened? The angle incidence is pi by 3. How did I go wrong? See, it is making pi by 3 with the reflecting surface. This is our reflecting surface. Please understand that. This is our normal. This is our normal. Yes? So this is our normal. Now think about it, my dear students. When the ray will come like this, this is the incident ray. The reflected ray will go like this with the reflecting surface. With the reflecting surface, it is making an angle of pi by 3. So actually this is the angle of incidence and this is the angle of reflection. Reflected angle and incident angle are same, and the angle of incidence will not be pi by 3. Obviously it will be 90 degrees minus 60 degrees, which is basically 30 degrees, or you can just call it as pi by 6 radians. That's the answer. So be very, very careful. What is asked, what is given. Yes, I made you visualize. Perfecto. Yes, angle of incidence and reflection is always measured from the normal. Many times the question paper setters confuse you with this and you lose marks. See, the paper is not difficult. Was this question difficult? Was this question difficult? Please answer in the chat box. No, right? What was difficult or what was tricky? The wordings. You misread or you misunderstood or you assumed something which is wrong. So that is what the game is. So a lot of people don't realize that the more questions you solve, that's when you improve. It's not about Bahating theory. Did you not know the theory? Everybody knew the theory. Angle of incidence is angle of reflection. Angle of incidence is measured with normal. Angle of reflection is measured with normal. Everybody knows theory. This is application. That's why you attend these classes. Moving on to the next one. The different types of beams. The different types of beam. Hello Viju. Hello everyone. So beam is a collection of rays. Beam is a collection of rays. One ray, singular. Multiple rays together. Like when I turn on the torchlight of my phone. Okay, let me show you. This is a beam of light. Yes or no, guys? Isn't this a beam of light? Right? It's a big collection of rays. So that's a beam of light. So there are three kinds of beams. The first one, when all the rays are parallel to each other, that time it is called as parallel beam. That's pretty much simple. All the rays are parallel. The width is neither increasing nor decreasing. The second beam is a divergent beam. That means the rays go away from each other as they proceed. As they progress, they go away. They don't like each other. They are going away. Or imagine a source of light emitting these light rays. Another one is convergent beam. If you have a lens or a mirror, the rays might accumulate at a point. They concentrate at a point. Just like you hold a lens in front of a paper, the rays of sun accumulate, converge at a point. That is a convergent beam. You can create all these three beams using a combination of mirrors or lenses. Remember that. So any mirror combination with lens combination, etc., can give you any of these beams. The next important definition is of an object and an image. Object is something which you keep in front of the mirror or the lens, whose image is formed after reflection or after refraction. Object generally creates those rays. Image is where the rays appear to meet or appear to originate after the reflection or after the refraction. Like when I stand in front of the mirror, I am the object. The person whom I see inside the mirror is my image. Correct? Yes or no? Very good. Now there are two kinds of objects. One is a point object. Second one is a large or an extended object. What is the significance of these two? For a point object, what happens is the rays of light will originate in every possible direction. So a point object will create a point image. Like an ant is almost like a point. A small insect or a dot on the paper when you touch your pen is like a point. That point will create a point image. Whereas an extended object is an object like me or you or this pen or the compass box or any desk or table or the wall or a tree or a bird. That is an extended object because it is made of multiple points. If by some method you are able to locate, the image by the point object, okay, because of this object the image is formed here. So you are able to locate the image by a point object. You can also find the image by an extended object because an extended object is made of many points. Yes or no? So because of this point the image is here. Because of this point the image is here. Because of this point the image is here. So the total image of this object is over here by joining all the points. So that is the significance of dividing an object into point or extended. An extended object is just made of points. So for every point you can find the image, and that's how you get the image of the big object or extended object. Everybody clear? Yes, I am going to come to real and virtual also. Yes, I know it is a little bit confusing. Many of you get confused with this. Great. How many of you get confused between real, virtual, image, object? Raise your hand. Suchi Mama already told this. And I hope you guys are already making notes. Yes? Yeah, you're making notes, or even if you're not making notes, if you have already made notes and you're revising through the lecture, I hope you're referring through your notes or NCERT at least. Okay, so let me clear it out. Let me clear it out now for all of you. Real image, whenever you think of real image, think of your favorite movie. Real action hero. Who is your action hero? Who is your favorite superstar? Whichever movie you want to imagine, just imagine. That is real. That is real. That is your real superhero, real heroine, whatever you want to imagine. It could be maybe the latest movie Pathan, or it could be some Thalaiva, or it could be Alu Arjun, or it could be Vijay, or it could be Amitabh Bachchan, it could be anybody, guys, I don't know, whosoever you like. So basically the real image is the image which is formed on the screen. And if you have visited a movie theater, you would have seen that from a projector the rays meet at a point. The rays meet at a point. So when the rays meet, that is real image. And the rays actually meet, that is real image. And to see that image, you have a screen so that you can see or form that image on the screen, and then you can actually perceive it. If there is no screen, then the rays will just meet and proceed ahead. So you need a screen so that you can actually see it, or else image is formed, but just that you might not be able to see it. Understood? That is real. Virtual is not where the rays meet. The rays appear to originate. Appear to, or rather not originate, appear to meet, I would say. Look at this. This was a real image where the rays actually meet. Where the rays actually meet over here. Okay, you can see that the rays actually meet at that point. This is like your movie theater. Like from a projector, the rays are formed, meeting over here, the image is formed over here. In case of virtual, you will see that the rays appear to meet when extended backwards. appear to meet when extended backwards. Like for example, imagine I am standing in front of a mirror. I am this side, this is the mirror. I will see the rays appearing to come from behind the mirror, as if something is placed behind the mirror and the rays are coming from that point. Actually, they are not coming from there. The rays might be getting reflected and bouncing back only when you extend it. So that's why this dotted line is shown. And you feel that since the rays are coming from a point, you feel that as something is placed over there. So that image is just a sensation, is just a feeling, something which is a fiction of your mind which is created. Your brain is making it. So that is called as virtual. So the image which you see in a mirror is virtual. The image which you see in a movie theater is nothing but real. Everybody clear? Okay. So rays actually meeting is real image. Rays appearing to meet when extended backwards is virtual. So just looking at the ray diagram also you should be able to figure out. Great. Now, do you know that just like you have real image and virtual image, you also have real object and virtual object? It's the same thing, just that the rays are just flipped in direction. Just change the direction, just flip the direction, you will get the real object and virtual object. Example of a real object is an actual object, like my phone. It's an actual object. The rays are actually coming from that particular object. Look at this. This is a real object. The rays are actually coming from that point. Notice this diagram and notice this diagram. What is the difference? It looks very similar. Solid lines, what is different? Only the arrow mark is different. The arrow mark which was here is now coming out. The arrow mark which is inward is now coming out. That's all. The rays actually, really come out from that object. That is why it is called real object. Ulta, correcto. Yes, Nani, I am taking regular classes. Yes, Swayam, concentrate on this chapter. We'll focus on what is next in the comments. If you put it up in the comments now, sir, please conduct this chapter, then I will take it up. Or if you don't put, I'll be like, okay, students know everything, so you have to put it up in the comments. Okay, so this is what a real object is. Virtual is also ulta, complete opposite of this. Wherever you see the rays coming out, just change the arrow mark. So the rays appear to converge, not diverge, appear to converge at a point. This is where the virtual object is. Virtual. Actually, it is not there. It feels as if the object is over there because you're making the rays meet at that point. But actually, it is not able to meet over there. Example will be like a hologram. You might have seen some action movies or fictional movies, sci-fi movies, where suddenly, just like when you video chat using WhatsApp or Skype or whatever you use, you see a video of the other person, your friend, relative, right? Imagine the actual person comes over there. Imagine you're talking with your friend, or imagine I am right now as a teacher in front of you on the screen. Imagine I come in front of you. You'll be like shocked, right? It will be like you are actually in a classroom. But if you touch, nothing. You can just put your hand through me. That is a virtual object. You feel it is there, but actually it is not there. Understood the difference? Everybody understood all the four things? Who is this? This is like your movie theater. Real image is movie theater, projector's image. Virtual is when you see yourself in the in the mirror. When you see yourself in the mirror, that is virtual. Next, real object, actual, real. It is a real object. Actually, the rays come out. Virtual object, think of these messaging apps, video messaging apps, but the image is created in such a way that you feel the actual object is over there, but when you put your hand, it is all transparent. Nothing is there over there. Holographic effect. Clear? Understood? Perfecto. Excellent. Now, what are the rules for image formation? Simple. See, whenever you want to form an image, whenever you want to know where the image is formed, you have some traffic rules for riding bikes, same way you have rules for finding where the image is. These rules help you to find out how and where that image is formed. The rules are very simple. Number one, you need at least 2 rays to form the image. Without 2 rays, how can you find where they are intersecting? Think about it. When I talked about real image or virtual image, just if I draw 1 ray, I don't know whether it is meeting or appearing to meet, or I have to pull it back. So I need at least 2 rays. The moment I see 2 rays, oh, they are meeting, then it is a real image. Oh, they are not meeting, they are diverging from a point. Oh, it's a virtual image. So you need at least 2 rays to form an image. Light rays, after falling on a flat surface, follow the law of reflection. So whenever you see reflection happening, always use angle of incidence is angle of reflection. Only then you can find the actual image. Next important thing is, when you see that intersection of reflected light rays occurs, only then image is formed. Very important. Only when intersection of light rays happens, only then image is formed. Like, sir, if I have 2 rays, they will intersect. No, think about it. If it's a convergent beam, it will intersect. If it's a divergent beam, you pull it back, it will intersect. What if it is a parallel beam? What if it is a parallel beam? Will it ever intersect? Will 2 parallel rays ever intersect? No, right? So then, if I have 2 parallel rays after reflection, you will be like, sir, is it a real image or virtual image? I'll be like, no, image only, man. There is no image only. Exactly. So there is no image formed. So that's why you need the rays to meet or appear to meet or diverge from some point or to some point. Remember that. Okay? Only if the rays meet physically, then the image formed is real. If they appear to meet, they do not actually meet, and then the image is basically virtual, just like I showed you over there. Is everybody clear about this? Niveda Vasudev, you are going to get the PDF of this lecture in the Telegram channel. The link of the Telegram channel is there in the description box. Join it. So after the lecture is over, maybe in few hours or maximum one day, I'll be posting in the PDF. Everything you get it in our Telegram channel. Yes. Hello Roman, Regnis, welcome Bacha. Ready for a question? Let's see how many of you can figure this out. What do you think is this? Is it a real image? Is it a virtual image? Is it a real object or is it a virtual object? Look at the direction of the rays. Look at the arrow marks. That's very, very crucial. Only then you will get the answer. Come on, I want everybody answering this by spamming in the chat box. Let's see who is going to get this correct. I want to know all the students. That's the only way I get to know your names here. If you stay silent, I will be like, I don't know, ghosts are attending or zombies are attending my class. So you have to post the answers and you have to keep posting it until your name registers in my head. And then when I meet you during felicitation function, when you get 600, 650, 700 marks in NEET, I'll be meeting you. Obviously, you'll be getting that many marks. Why? Because you're attending my classes. Okay. So then I will be like, oh, this was that Sampath. Oh, this was that Swayam. Oh, this was that Rakshan. Oh, this was that Pooja. This is that Suchi Mama. Oh, this is Tarika. Oh, this is Paleti. Oh, this is Kirti who was attending my class, answering it. Oh, now you have 650, 700 marks. Very good. Which AIMS are you going? Which AFMC are you going? I will be asking you such questions. Okay, the correct answer for this obviously is a virtual image. Yes, this is a virtual image because remember the rays appear to meet when extended backwards. They appear to meet when extended backwards. The moment you see that dotted line, the thing that should ring in your head is virtual. It has to be virtual because they are not actually meeting. You have to pull it behind. And because they appear to meet behind, that means it feels as if something is over there. Remember that. Okay? That's it. Awesome. If it was virtual object, then these arrow marks will be exactly opposite. They will meet at that point, not diverge from that point. They will actually meet at that point. You will feel like that object is created over there for you. You will feel like that. Okay, but here it is coming from that. Think always of that example of the mirror. When you look at yourself in the mirror, the rays appear to come from behind the mirror. So that is how you can remember it. Okay, which of the following are true? Yes. Gopika, no problem, bacha. Even if you're a dropper, there are many dropper students just like you attending these classes. Oh, by the way, since is are mentioned, more than one option may be correct. Can you photograph a virtual image? Real images are formed only when screen is present. Okay. For an object placed in front of a mirror, the image is virtual. Okay. Real image can be photographed. Come on. Let's see how many of you can do this. Siva Sankar, you have missed a little bit, but not so much. I'm pretty sure this much part you would know it if you have studied basics. But if you have not, then you can just rewind a little bit and catch up at 2x speed, and you can join me live. Okay. Sampath is saying all of the above. Harini is saying BD. Viju saying what is it? AD, BD, C, BD, C, B, BCD. Kirti saying BD, Asa saying DA, Irfana saying BD, Harni saying BD, Natarajan saying BD. Interesting. Most of you BD or CD. All right, interesting. So let me tell you, many of you got it wrong, especially that B option. I feel B option. Like I was telling, yes, see, B option is not correct, guys. How is B option correct? Real images are formed only when screen is present. That is wrong. See, understand the wordings. Real image. Okay, let me go back. Where is it? Here. Real image is formed only when screen is present. Wrong. Real image can be seen only when screen is present. Understand the difference. Image is formed, just that you cannot see it. You need a screen to see it. Understand. Image is anyways formed the moment the rays meet. So that is a wrong statement, guys. Read it carefully. Let me go back to that. Real image is formed only when screen is present. Wrong. Real image can be seen only when screen is present. That would be correct. Understood? Yes, we test via screen. Correcto. Gopika, I don't know what's your current state, bacha, how many marks you're getting. So it's a little bit difficult. But if you are doing at least average, I feel you can get into, I don't know, maybe the topmost aims, but at least some other aims. The new aims also at least you can get. It is possible in the next 2-3 months. Definitely. Can you photograph a virtual image? Guys, virtual means your mirror. Mirror, right? When you see yourself in a mirror. Haven't you seen on Instagram? People posting, celebrities posting. They go to the bathroom, 5-star hotel bathroom, and they click a selfie in the bathroom of their image. Obviously, you can take a mirror selfie. You can take a photo of you in the mirror. That is a virtual image. Obviously. Can you take the photo of real image? Real image means the image which is formed by a projector. Obviously, you click a photo while you are watching some movie. Let's say you watch some movie, okay, whatever. Let's say Avengers. You can obviously take a photo and post it on social media. Hey, listen, I was watching this movie. Everything will be seen, whatever was there on the screen. So definitely you can photograph real image also. For an object placed in the mirror, the image is virtual. That is true. So if you are standing in front of the mirror, the image is behind. It is virtual because the rays appear to come from behind. Exactly. Very nice question. So I am loved this question. The example that no one can disagree. Sir, sometimes from NCERT words are not clear as simple English. I agree. NCERT is not a good book for learning. NCERT is a good book for, preparing for the exam. Understanding the concepts. So concepts you cannot really understand through NCERT. If you read NCERT, you will be like, what the hell is happening? So the best book to understand concepts for JEE, NEET, whatever, is always the only book, which I always tell. Come on, those of you who have been attending my classes should tell the book name. Put it up in the chat box. I'm not even going to tell it. For all those people watching it recorded, please refer to the chats. Let's go to the next point. Okay. What do we have? Plain mirror. Who is this? Monkey? Oh, it's not a monkey. It's a it's a pot. From here it looked like a monkey. The screen is also reflecting. Anyways, so guys, we have a pot in front of a mirror. It's a plain mirror. So what are the different things that you can tell? Exactly. Many of you have told. Yes, very good. H.C. Verma. That's the book. That's the book. Perfecto. For reading theory. That's the best book and the only book from which you should learn theory from. And what are the different things that you can look and see and conclude from this particular photograph? First, the image is erect. The image is erect, correct or no? It's not like the flower pot or the pot is upside down. You are standing like this. Imagine your image is ulta, your leg is on the top and your head is below. You'll be like, what the hell? And then you do this, then your head below starts moving. If you shake your leg, you see your leg on the top starts moving. You'll be like, what the hell is this mirror? So it is erect. If it was opposite, then it would be inverted. Inverted images can also be formed by using curved mirrors. Okay. Second thing, when you see yourself or when you are seeing this pot, is the pot very big? Or is the pot very small? No, right? It's of the same size. It's of the same size. Everybody understands this? Everybody understands this? Very good. Perfect. It is virtual. Very good, Tarika. It is virtual. Obviously, it is virtual image. Perfecto. What else? It's at the same distance. Imagine you are standing at 3 meters from the mirror. Your imaginary person, the image, is also exactly 3 meters. It's not like 100 kilometers. Where is that guy? Or very close. No. It's the same distance. So basically, image distance equals to object distance for a plane mirror. Somebody was also telling about lateral inversion. Who was that? Suchi Mama. Gopika, first of all, follow all my crash courses. Follow my strategy which I have given. You can just go back to the past videos. Number 2. Number 3, don't give up and don't feel demotivated. Think this is the last attempt and you have to crack it. I'm not going to talk about drop, because the moment I start talking about drop, you will start taking things lightly and you'll be like, I have 1.5 more year, I can just chill out. No, you have only this attempt, that's it. Okay, we are not going to talk about drop until I get your report card. Alright, yes, lateral inversion means left becomes right, right becomes left. So if you are a right-handed person, you are writing, like I am a right-handed person. My image, probably you can also see my image in this blackboard, I don't know. My image is seen in the blackboard or not, or depending on your screen quality and all of that. So there is a small reflection which happens over here. Probably you can also see the room behind sometimes. So you will see the person in the reflection will be left-handed person. He will be writing like this. So if I am writing like this, the person in the reflection will be writing like this. This is left-handed person. This is left-handed person. Yeah. Okay. So basically, it is called as lateral inversion. Right becomes left. Left becomes right. Lateral inversion. This is also a very, very important pointer. So all these are important things regarding how the image is formed by a plane mirror. Very, very crucial. If you had to draw a ray diagram for the image formed, this is how you're going to draw it for your boards especially. So you will be given a mirror, or you have to draw a mirror. Okay, and then what you're going to do is take up a point object, and then take up any 2 rays. Let's say this is ray number 1, which is incident like this. It gets reflected like this. Okay, this is ray number 1, and you extend it backwards. Maybe somewhere over here. It's going to be extended backwards like this. Then you take another ray, maybe, I don't know, either here or maybe even here, doesn't matter, like this. So this is incident like this, it is reflected like this. Now extended backwards like that. You can see this ray and this ray both are diverging. When extended backwards, they meet over here. So this is exactly the point where the virtual image is formed. This is how you can find the image by a plane mirror using the laws of reflection. Angle of incidence is angle of reflection. Angle of incidence is angle of reflection. All the rays are in the same plane, right? I hope this is very, very clear. Understood? Very nice. Very nice. I have a mirror right now to see you left-handed. Very good, Siva Sankar. Siva Sankar is watching the lecture using a mirror. Very good. Very good. And you would have also seen ambulance. The word ambulance, oh come on guys, you guys are going to be doctors, and you would have seen the word ambulance on ambulance. How is it written? How is it written? Come on, everybody answer this. How is the word ambulance on an ambulance written? Have you seen the word ambulance on an ambulance? If not, please see it next time. Come on guys, you're going to be doctors, you're going to be in hospitals, clinics, and you're going to see ambulances many times. So it's always written inverted, not reverse, laterally inverted. Why? So that if you are driving and you see an ambulance behind, then the word ambulance looks proper to you. If it is written proper, then it will be inverted, then you will be like, what is this? So that is the reason why it is written in that manner, so that when it is flipped, then it is seen properly. Okay, laterally inverted. Great. Okay. So Virangul, I just conducted a class few days back on how to study for board examinations. win between NEET. So please watch that lecture. I have given a complete strategy. It's there, just few days back I have given that. Next important thing, guys, for a plane mirror is the angle of deviation. This is the angle of incidence. This is the angle, or rather this is the incident ray. This is the incident ray. This is your reflected ray. This is your reflected ray. This is the intended path. Without the mirror, the ray would have gone like this. The ray would have gone like this, but it turned by this angle. So this is called as the angle of deviation. This is basically called as your angle of deviation, delta, and this delta is nothing but 180 minus 2i. Very important formula. What is I? I is angle of incidence. 180 degrees minus 2i is the angle of deviation. As simple as that. Everyone? Great. Let's move on to the next point. Is nothing but the image velocity with respect to the mirror, object velocity with respect to mirror, and all these things. So every time you get these questions, many students I have seen they get confused. Now next time you get this question, you will not get confused because I'm going to give you a trick, a shortcut formula. Let's see what that is. So when your object, your mirror, everything is moving, object, mirror, image, everything is moving. So let's say, Vm is the velocity of the mirror, Vo is the velocity of the object, Vi is the velocity of the image. Image velocity, mirror velocity, object velocity. Everybody fine till this point? Everybody fine till this point? Sir, what if I value is different? Even if the I value is different, it's okay. If it is 20 degree, 20 plus 20, 2i, 40. So 180 minus 40. If I is 60 degree, 60 plus 60, 120. So 180 minus 120, which is 60 again. So you put the value of I, you will get the value of deviation. It will be dependent on the I, the deviation. Is that okay, Meenaram? Okay. Now what happens is, if you look at this entire situation where image is moving, object is moving, mirror is moving, this is moving, it looks confusing. But if you sit on the mirror, it looks easy. So in the mirror frame, with respect to basically your mirror, you will see that the object, if it is moving like this, then the image has to move, exactly opposite and with the same speed. Why? Because if I move 2 meters close to the mirror, the image also should come 2 meters closer to the mirror, because object distance is image distance. Object distance is image distance. So to make sure that happens, object and image velocities are always equal. So I would say the velocity of object with respect to the mirror and the velocity of image with respect to the mirror are equal, but in vector form it is opposite. So I will put a minus sign. Everybody with me on this? Meenaram, that I1 plus I2 and A, that formula is for prism. You are getting confused. This is deviation only for plane mirrors. I am not talking about prism. What you are referring to is prism formula. Now what happens next is VOM. V12 is V1 minus V2. VAB is VA minus VB. VOM is VO minus VM. So this will be nothing but VO minus VM is equal to negative of VIM will be VI minus VM. Yes or no? This will be VI minus VM. Okay, just open up the bracket. This will be minus VI. Minus minus becomes plus. So plus VM over here. This is minus VM and this is nothing but VO. So take VI over here. So it will become VO plus VI is nothing but VM plus VM is nothing but 2 times of VM. Now this is the formula which you are going to remember. From this you can solve any kind of question. VO plus VI. Object velocity plus image velocity is twice the mirror velocity with proper sign convention. Okay, everyone, let's try to do some questions on this maybe. Example, I tell you. Let's say the object velocity is 5 meters per second like this. Example. And let's say the mirror is moving like this with 2 meters per second this way. How are you going to solve the problem? Start with the formula. Velocity of object plus velocity of image is 2 times of the mirror velocity. What is the velocity of object? 5. What is the velocity of image? I don't know. I have to find that out. What is the velocity of mirror? It is 2. So into 2. So guys, this will become 5 plus Vi is equal to 4. So just shift it over there. So Vi will be nothing but 4 minus 5. So Vi will be minus 1 meter per second. What is this negative telling you? This negative is telling you the image is not going right side, it is going towards the left side. Left side, that's all. So sign convention I have not yet come to it, Swayam. I will talk about it in the curved mirrors part. So it is going 1 meter per second towards the left side because it is negative. If it was positive, it was right side. Let's take another example so that you guys are very, very clear about this. Imagine I take some another problem. Okay, I'm just going to change the values over here and see if you guys can get this time. Okay, so imagine I change the values and I make the mirror go like this with 4 meters per second and the object is going with, let's say, 1 meter per second like this. Imagine, just example. Okay, so let's try this out. So in this case, again the same formula I'm going to use. Object velocity will be 1, but the mirror velocity will not be 4, it will be minus 4. Do you understand it? Why is it minus 4? Because it is going towards the left side. So 2 into negative 4 will be minus 8 and this will be 1. So take 1 towards that side, minus 8 minus 1, it will become minus 9 meters per second. This is how you're going to solve the question. Everyone, is the velocity of the object and image with respect to the mirror is same but not VO is equal to VI? Yes, because vector Siva, VO will be negative VI because of the signs, directions. They are opposite. Magnitude wise they are equal. So VOM magnitude wise is equal to magnitude of VIM, but when you put a bar symbol, because both will be opposite, that's why you need to put the minus sign. Is that okay, everyone? Got it? I think Minaram, I just told you that is different formula for prism. We have not yet talked about it. Forget it. Just concentrate on this thing. Okay. Last type of question, direct questions have come in NEET. You know what is this? If you have visited some trial room or a barber shop, they put a mirror behind you and there is a mirror in front of you and you see many images formed. Or when you are in a changing room, there is a mirror here and mirror here. And if the mirrors are making small angle, you see many images of you as if there is an army of your images in a big circle. Many images formed in a big circle. Correct? Yes or no? So the same thing is happening here. This is the object. There is a mirror here. There is a mirror here making an angle. You will see there will be an image formed here. This image's reflection is formed here. This reflection formed here. This reflection formed here. So multiple reflections are formed and all these images are in a circle. What are they? All the images are going to be formed in a circle. So first important thing is all images are formed on a circle. Very important. Okay, great. Next important thing, how many such images are formed can be found by using this formula. What is theta? Theta is the angle between the mirrors. This is that theta, the angle between the mirrors. Theta is the angle between the mirrors. I don't know whether you are able to see it, so let me put a different color. So this is basically your theta, angle between the mirrors, that's all. Then the number of images, 1, 2, 3, 4, 5, 6, whatever it is calculated using this formula. 360 you divide it with theta. Let's say for example theta is let's say 60 degrees. 360 by 60, how much is it? 6, right? Okay. If it is even, then subtract 1. If it is even, 6 is an even number, okay, then subtract 1. So 6 minus 1 is 5. So the total number of images is 360 by theta minus 1. If it is odd, then leave it as it is. It will be 360 by theta only. It will be 360 by theta only. Just imagine the angle between the mirrors is 120. Angle between the mirrors is 120. So 360 by 120, how much it is? 3, right? It is odd, right? So the answer will be 3 images. Answer will be 3 images. Understood? So if it is odd, keep it odd. If it is even, make it odd by subtracting 1. That's the concept. What you have to subtract? 360 by theta. Let's see if we can solve these questions. Gopika, if you're a CBSE student, even better, because many things are relatable from CBSE and NEET. Number 1. Number 2, you have 2 months. Utilize those 2 months rather than sitting and crying of what is not done. Number 3, There are only few chapters which you can do, and only with those few chapters also you can score easily above 100. That strategy also I have given on this channel. Number 4, how to concentrate with boards and NEET, that strategy is also given. So follow these things, trust me, you will thank me later after 2-3 months. Okay, it is desired to photograph the image of an object placed at a distance of 3 meters from the plane mirror. The camera, which is at a distance of 4.5 meter from the mirror, should be focused at a distance of, come on my dear students, let's start drawing the diagram to get an idea. So let's visualize it. To photograph the image of an object placed at a distance of 3 meter from the plane mirror. So the object is placed at a distance of 3 meter. Obviously, the image of that object is going to be formed exactly 3 meters behind. So the image will be formed over here. Now the question says that there is a camera at a distance of 4.5 meters from the mirror. So our camera is basically somewhere here maybe. Okay, I'm just showing a random camera. So this is your camera, and this camera is at a distance of 4.5 meters. So where should your camera basically focus? It should focus over here to see this image. So what is this total distance? What is this total distance from here to here? How much is this total distance, guys? It is nothing but 4.5 plus 3, which is nothing but 7.5 meters. Is that option there somewhere? Sivasankar has already told it. Yes, option D. D for AIMS Delhi, right? Yep. Hari, I am a physics teacher. Okay. All right. Hello, Laksha. Welcome all the students, guys. Okay. So very simple question. Just concept of object distance being equal to image distance. Moving on to the next question. Two mirrors are at an angle of 60 degrees. Then the number of images formed by them is, come on, this you should be able to give it instantly. I just gave you a formula which is for odd and even. Odd and even. Come on, everybody should spam this. If two mirrors are at an angle, all the images are formed on a circle. The number of images formed is given by a formula 360 by theta minus 1 or 360 by theta, depending on whether it is even or odd. Okay, it's more than enough. After this, Sinchan, you should be able to back to NCERT, read by heart the definitions, solve the back exercise, solve the problems, go through PYQs, and I'll be doing special board classes in the days to come. Don't worry when board exam is going to start. Okay, so yes, the answer is 5, because the first thing that you're going to do is 360 divided by theta, which is 360 divided by 6, which is basically 6. Now 6 is an even number. The moment it is even, the total number of images will be 6 minus 1, which is basically 5. So 5 images will be formed. That's option number A. Perfect. Moving on to the next one. The velocity of the image, when the object and the mirror both are moving towards each other with velocity of 2 and 3 respectively, is how much? Draw the diagram, use the formula. Draw the diagram, use the formula. I just gave you a trick. You will never get a wrong answer using that formula which I have given to you. VO plus VI is twice VM. That's the formula. Learn how to apply it. I just showed you a few examples as well. Welcome, Sinchan. Why images can't be even? That's because what happens is, if you try to manually draw it, you will always see that one of the images gets overlapped. So that's why that if you have 3 here and 3 here, okay, then one of the images gets overlapped when you place the object symmetrically. So because one of them gets overlapped, the number of images becomes odd in number. That's all. Okay. Many of you are saying 8 or minus 8 basically. Yes, looks like you guys are correct. Perfecto. So let's try to understand how to solve this. The object is going with a speed of 2 meters per second. The mirror is going towards the object with a speed of 3 meters per second. The question is, what is going to happen to the image? Now, I know the formula which I have to use. It is VO plus VI is twice Vn. Object velocity is 2. Image velocity, I do not know. The mirror velocity is 3, but with a negative sign because it is going towards the left. So it will be minus 6. So therefore, Vi will be minus 6. Take this 2 over there, it will become minus 2. So it will become minus 8 meters per second. That's the answer. Excellent, guys. Proud of all of you. Aren't you getting confidence now on the plane mirrors reflection concepts? Aren't you feeling that difference in you already? Next concept, the last concept in plane mirrors is how much height you require to see yourself completely. Imagine, my dear students, that there is a Pandu. Imagine that we have a Pandu over here. Pandu wants to see himself. He is getting ready for a date. He is going to see Champa. So he wants to see from head to toe. Is he dressed neatly? Is he wearing the right shoes? Is his hair fine? Is his tie and jacket fine? Is his pants fine? Is his hands well dressed? Does he have a good watch? How is he looking fit, tight, everything? So he wants to see himself. This is Pandu. Okay, very, very good looking Pandu this is. And then there is a mirror which he needs for seeing himself. How? And Pandu is a physics student, right? So he is going to think how big that mirror should be. Should it be this small, that small? What is that minimum size required for Pandu? Very good. Siva is going to kill this chapter tonight. First of all, think what is Pandu going to see? Pandu is going to see himself behind the mirror. So imagine a secondary Pandu, a twin Pandu behind the mirror. Okay, so exactly at the same distance roughly, I'm just going to draw a similar kind of Pandu over here. I hope it looks very similar. Okay, so this is that similar identical Pandu. Great. Now, if this guy has to see this guy completely, that means all the rays from the top till the bottom should be able to reach his eye. So from the top, it should be able to reach his eye means like this. The rays should be able to reach like this. And from the bottom, it should be able to reach his eyes. That means like this. But remember one thing, actually the rays are not here. The reason being, it's behind the mirror. So I will make it as a dotted line. So I'm making it as a dotted line because I know it's behind the mirror. It's behind the mirror, so that's why I'm showing it as dotted line. Actually, the rays are coming like this and getting reflected and entering his eye. This much mirror only is required. This part of the mirror is not even required. This is not even required. Think about it. Why is this even required? Not required at all. Because the rays are not even getting reflected. All the rays in between this only are entering the eye. This is the part which is required. Everybody agrees or disagrees? This is the only part which is now required. Yes or no? Yes or no? Everyone? Perfect. Now guys, look at the triangles. You will get the idea of this. This is a big triangle. Okay, this is the base. This base is basically height h. Correct? And then you have the mirror in between over here. The mirror in between over here. Now observe this triangle. Observe this triangle. And also observe another triangle which is big. This triangle. The big triangle and the small violet triangle. Aren't these two triangles similar? Aren't these two triangles similar? Similar triangles, yes or no? Similar triangles, yes or no? Everyone with me? Perfect. So, because object distance is equal to image distance, object distance is equal to image distance, shouldn't this be half of this? Shouldn't this be half of this from here to here? If it is 10, this should be 5. If this is 6, this is 3. If this is 8, this much is 4. Yes or no? So, can't I see that the ratio is basically 1:2? The ratio is basically 1:2. Yes or no? Everybody able to visualize it? Perfect. This triangle is half of this triangle. They are similar. You stretch it everywhere. So if you stretch it 2 times, it will become that big orange triangle. The violet triangle becomes the orange triangle when you expand it 2 times. 1:2 ratio. So that means if this is h, what will this be? If this is 2, this is half of it. If this is 1, this is twice of it. So h, so naturally this will be h/2. So the minimum size required, this is the minimum size which will be required, will be h/2. Understood? Yes or no? Did you love the proof? Did you love the way I showed it to you? Okay, using similarity. That's why I told you also at the beginning that geometry is involved. Angles, triangles, parallel lines, this, that, so many things might be involved. Perfect, perfect. If 360 by theta is not an integer, such questions, Bhuna, will not come in your NEET exam, because then the another formulas or other sub cases come into play, number one. Number two, in those cases, it is always advisable that you actually draw it using proper reflection. Draw the reflection here, draw the reflection here, and then you get it. But there is formula way also, but then you have more sub cases for that. Okay, so you ignore that because that is not going to come in NEET. That is not a part of NEET. All right, so I have put up the printed version of that as well. Okay, so that brings us to spherical mirrors. Plane done. Now sphere, curved mirrors, like your spoon. You might have seen. Look at this guy taking his picture. I don't know whether you can see him. This is the which side and which is this side. What is this surface called? This surface and this surface. You can see there is a ball over here, big steel ball. You can see yourself, it's looking very distorted because it's a curved mirror, it's not a plane mirror. Or you might have seen those magical mirrors. The mirrors are bent, curved, and you see yourself in a very funny manner, wavy manner, sometimes big, sometimes small, because the manner in which the mirror has been constructed. Yep. This one is concave. The one which is like a cave. Cave means you scoop out something. So that's a concave. Vex is going to come out. Cave's opposite is vex. So convex is the bulging surface facing you. That is the convex surface. You will see many applications of mirrors. Okay, like I told you, the house of magical mirrors. Suddenly you see your hand appearing so big. Look at this guy's hand in front of a curved mirror appearing so big, only because the mirror is curved. Actually his hand is not so big, it feels like that. Or you see these kind of mirrors placed in the parking lot or on intersections, so that you can see what is coming onto the other side. It has a big field of view. So the use of this mirror is, when you place a convex mirror, you can see objects coming from that side also, this side also. So you know, okay, you have to brake or you can go safely or not. Okay, so that's the application of it. Now, coming to that section 9.2.1 of your NCERT, what is it? It's basically sign convention. And many students face difficulty in sign convention because you just by heart it. No, simple rule. The rule is, if something is up, it's positive. If something is down, it's negative. Up and down is simple. Something is up, it's positive. Something is down, it is negative. So height up is positive, height downwards is negative. Very simple. Problem is with left and right. Which side is positive, which side is negative? A lot of people by heart like this. Right side is positive, left side is negative. No, that's not correct. The direction of the incident light should be taken. The direction of the incident light should be taken. If incident light is going like this side is positive. If actual incident rays are coming this way, then this side is positive. So the manner in which the incident rays are going, that direction becomes positive. I will write it down for all of you. I'll write it down for all of you. Where is it? The direction of incident rays is towards the positive side. That's all you should remember. Okay? Keep this in mind. Yep. All right. Is only PYQs enough? No, definitely not. It's definitely not enough, because you won't find so many PYQs, number one. Number two, the questions might not get repeated. Number three, there are so many other things that you need to learn first before going to PYQs. PYQs might actually harm your confidence if you are not well prepared. Okay. No, it's not necessary, Siva, that you always assume the light rays come from left to right. If it is coming from left to right, yes, that is true. But what if the rays are coming from right side? So then things will change, right? So that is why I told direction of incident rays is towards the positive. That's what you should remember. Is that clear? Everyone? Perfect. Next, center of curvature, radius of curvature, focus point, all these things are pretty much standard, but still I'll just show it to you. If you have this mirror, you can see this is which mirror? This is a convex mirror, right? I'll just put it over here. This is nothing but a convex mirror, because you can see the inner surface is silvered. You can see that here the outer surface is silvered, the inner surface is caved in. So that is why this is nothing but a concave mirror. So this is the center of curvature. You can see this is the imaginary sphere. It's not an actual sphere, it's an imaginary sphere whose part is this spherical mirror. Spherical mirror is just a small part of the big sphere, imaginary. The sphere center is center of curvature, the radius of the sphere is radius of curvature. Same thing, if you extend the arc, it will become a circle. The imaginary circle center, center of curvature, radius is radius of curvature. Okay, P is the pole, which is also the central line. And if you join center and the pole, so P is the pole, which is the central line or central point on the mirror. So if you join a line from the center to the pole, that is called as the principal axis. So pole is generally the center of the mirror. If you have a curved mirror, take the central point on that mirror, that is the pole. You join the pole and the center of curvature, that is principal axis. Okay, let's move on to the next one. Can we remember that with xy axis in graph Tarika? I would say no, that is not the right way. The right way to remember sign convention is to remember if something is in the direction of the incident rays, that side is positive, opposite to that is negative. That is the correct way. You might not be able to do it and for all the cases then Tarika. Right now, formula preparation and question practice enough for NEET rather than concentrating more on theory. Harini, theory-wise, just concentrate on the definition and experiments and facts. That's all. Otherwise, problem solving. Yeah, Sivasankar, that's not necessary. Like I said, left to right incidence is not always. Okay. Harshini, session, I don't know, bacha, it will be at least for 2 to 3 hours. Okay. We have not even done 1/3. Okay, so there are going to be 2 breaks in between. 2 breaks are going to come. Okay, next important thing, focus. What is focus? Focus is, come on guys, I want you to focus now. Come on, everybody focusing. Everybody focusing on the chapter right now. Everybody? Okay, let's focus now. So guys, come on. Parallel rays falling on a concave mirror, they meet at a point. That is called focus. Actually meet. They actually meet. So that point to the pole, that is called focal length. That point to the pole is called as a focal length. Second important point, if it's a convex mirror, then the rays will diverge. They appear to originate from a point. That point is the focus, and that distance from the pole is called as the focal length. Perfect. Now you guys only think and tell me, is the focal length positive or negative over here? Is the focal length positive or negative over here? Just quickly think and tell me. Think parallel rays of light incident like this. So obviously this side will be positive, this side will be negative. Yes or no? Great. Where is the focal point? Focal point is on the negative side. So focal length is basically going to be negative. Focal length is going to be negative. Perfect. Same way over here, incident rays are going this side. So that side will be positive of the pole and left side will be negative. Focal point is on the positive side. So focal length is basically positive. As simple as that. One more thing which you should know over here is there is a small relationship between the focus and the center of curvature. Focus and the center of curvature. What is that? What is that relationship? Probably you can see it over here. F is exactly between C and P. F is exactly between the circle's center and the pole. Basically, the radius is twice the focal length. The radius is twice the focal length. Focal length into focal length 2 times. So that will give you the total radius. So R, the radius of curvature, is 2 times of F. Keep this in mind. Everyone? Very good. Can you also notice one more thing? Over here, the radius of curvature is also negative because you can see center is on the negative side. Center is on the negative side. So not just F guys, even radius of curvature will be negative if you write it in sign convention. Here also, radius of curvature will be positive because the center, the circle's center, the radius is on the positive side. So radius is also going to be positive. That's how the sign convention works. If R is positive, F is positive. If R is negative, F is negative. Simple. Great. Let's see if you guys can figure this out. If the radius of curvature of a concave mirror is 20 centimeter in magnitude, then the focal length is, come on, everyone should answer this quickly in the chat box. I want everybody spamming the answer in the chat box because this is very straightforward. I'm putting all my hopes on you. Come on. With the proper sign, be careful. Okay, I don't know whether it's going to be positive or negative, you figure it out. Usha saying minus 40, Tarika saying 10, Giridhar saying 10, Astha saying 10. What about others? Sampath saying 100. I think it should be 10. Okay, you meant 10, I guess. Harni saying A, Sampath also saying A, Usha saying minus 10. Interesting, oh, interesting, oh. Akash saying minus 10, Janvi saying 10, Pooja saying B, Susanta saying 10, Pooja saying B. Interesting. Come on, come on, come on, come on, come on, come on. Paleji saying 10. Figure this out properly. Radius is 20. So magnitude wise, if I just look at it, magnitude wise, R is basically 2 times of focal length, magnitude wise. So radius is 20. Focal length is going to be 20 by 2, which is basically 10 centimeters. But this is magnitude, that's why modulus. Now it is a concave mirror. What happens in case of a concave mirror? The focal point is over here, right? So if the rays were going like this, they meet here. This was the incident ray. This is the positive side. This is the negative side. Hence, I should put minus 10 centimeters. Minus 10 centimeters, not 10. Option B. Understood, guys? Magnitude was 20 of radius. Magnitude of focal length is 10, but sign wise, because it is concave, it is negative. I just told you about this. You just told me here. For concave, it is negative. For convex, it is positive. So that's the reason why it is negative. This was convex. Answer would be option A. Clear? Oh? Clear? Oh? In foreign countries, MBBS is worth or not? It's up to you. Personal choice. Number 1. Number 2. If you just want to become a doctor and you do not worry about your you are okay with staying away from family, you are okay to change the culture, the lifestyle, and you are okay with staying alone, managing things alone, you can do things independently, then you should consider a foreign country. But if you feel that no, I want to be here, I want to serve my country, or maybe you want to be close, you cannot adapt to the food, lifestyle, the weather, and so many other things, then you should stay in the country itself. Okay, it's personal choice. Another thing is, when you consider foreign countries, you should also look at the geopolitical issues, especially Ukraine, Russia. So you should not go only right now. It's not worth the risk. But if it's some other country, maybe you can try. Also, another factor we should consider is the cost. So whether your family can actually afford that much of cost, rather spend the same money and become a doctor in India. Okay, so. But don't go to some random country and do become a doctor. Like somebody saying Philippines and all that. No, please don't do all that. Okay, it's a waste going to some random country. I have heard some students, I remember, told me, sir, I have gone to Cambodia. I'm like, what the hell? Why have you gone to Cambodia? Sir, it's a foreign country. It's a foreign country, but do you know what is the lifestyle changes, and do you know the cost of living over there and here? It's so low. It's in fact worse than India. So don't just randomly go to any country. Not any country outside India is good. Understand that. So be careful. Alright, great. So let's move on. What is enough, Yasin Bacha? Let's move on to the next question. I think we have the concept. Image formation by concave and convex mirror. So whenever you want to find the image of a concave mirror, there are certain rules. First rule. Okay, by the way, before going to the rules, the first rule, I'll tell you, how many rays do you need to find an image? Remember, I just told you, whenever you want to look at an image, you need 2 rays, right? So how do you get those 2 rays? Are you going to draw it by hand? No, simple. There are 3 rules or 3 important rays by which you can find the exact location of the image. Yes. So first rule is, if you draw a line which is parallel to the principal axis, it will pass through the focus. A line which is parallel to the principal axis, when extended backwards, will pass through the focus for a convex mirror. This is one of the ray. The second rule is this. If you draw a ray through the focus, it will pass parallel to the principal axis. If you draw a ray directed towards the focus, it will become parallel to the principal axis. So using these 2 rays, you can locate an image. Sometimes one of these might not be so easy to draw. So that's why we have the third rule. So any of the 3 rules you can use. So any of these 3 you can use, either these 2 or these 2 or these 2. But you need 2 of these 3. The third rule is, if a ray is passing through the center, it will get reflected as it is and pass back through the center. So it will retrace the same path. a ray directed towards the center will retrace the same path. So either these two, or this and this, or this and this will give you the exact location of the image. You can take a photo of this if you want to. I'll just move to the sides. Yep. Yes, I will be teaching optical instruments, human eye defects and all of that tomorrow. Gopika, I am from Maharashtra, bacha. Alright, cool. So, first rule, I'll probably just write it down over here. A ray parallel becomes, or rather passes through the focus. This is the first rule. The second rule, a ray which passes through the focus, that becomes parallel, exactly reverse. And this one, a ray which basically passes through the center of curvature, retraces the same path. So that's why the double arrow mark, the same path through C, same path through the center of curvature. These are the rules, as simple as that. Great. Oh, my class, 2 students from my state. Great, nice to see. Okay, great. So right now, Sachin, like you know, I'm only concentrating on the high weightage chapters, not all the chapters. I won't be doing all the chapters. I mentioned this before. Now, you can do this as homework. Place the object here, see where the image is formed. Place the object there, find where the image is formed. I made a beautiful table for all of you. You don't have to by heart anything, but just try to draw it. You will be able to do it in your own way. There are different ways you can only remember. It's actually very simple. When the object is very far, the image is formed at the focus. When you bring the object close, then you will see the object starts moving away from the focus towards the center, and finally at the center of curvature, the image is also formed at the center, exactly inverted of the same size. When you bring the object even closer, the image starts going further away, and when you bring the object at the focus, the image goes till infinity. So it's a very easy way to remember. Go from infinity, bring the object close to the center and then to focus. Exact same thing will happen with the image. The image will go from focus to infinity. And when you bring the object closer than the focus towards the pole, closer than the focus than the pole, towards the pole, then you will see a virtual image is formed. The image is no longer real. The image is found behind the mirror. It's a big, enlarged, erect virtual image. That's what happens. Everyone? Okay, great. And for convex mirror, it's very simple. Whenever you have a convex mirror, the images are always small, diminished, erect, and they are virtual. Every time you will see that it is diminished, virtual and erect. There is no positions over there. At this point it is here, at this point it is here. Every time it is going to be small. So that is very easy to remember for a convex one. Only for a concave mirror, there is a small chart. Don't even have to remember, just visualize it by drawing. Okay, so I'm just mentioning it over here. Draw and revise, and that's how you remember. Just draw this at different points. I think you would have done this in 10th, yes or no? Have you done this in 10th standard when you were in 10th grade? I hope you gave the exam when you were in 10th. Maybe some of you Corona batches did not give the 10th exam, I don't know. Okay, cool. So let's do a question maybe after this. Okay, so mirror formula. Yes, you have done this. And even the mirror formula I would have done. What is the mirror formula? See, this way of finding where the image is formed is a geometrical way, where you basically are given a mirror, you know the object, you draw the rays, and then you draw another ray. Oh sir, the image is formed over here. Okay, so you locate the image geometrically. But every time you cannot use pencil, scale, protractor, compass, this and that, and find the image. So there is a numerical way, and that is a mirror formula, where you know the object distance, you know the image distance, you know the focal length. Using this formula, you get everything. So over here in this formula, obviously F stands for your focal length. Focal length. U stands for object distance. V stands for image distance. Image distance. Now please remember one thing. Object distance, image distance, focal length, they are all sign sensitive. They are all sign sensitive. Meaning you need to put it properly with the plus or minus sign. In this example, don't you see this is the object, this is the image, or if you're not able to see that, no problem. Let me just give you an example over here. Just imagine that there is an object over here, okay, and the image is formed over here, okay, and this is a mirror. Can you quickly tell me the sign of U, V and F? Can you quickly tell me the sign of object distance, image distance and focal length? Let's see how many of you can do this properly. Object distance. Okay, so for doing this, what you're going to do is think how the incident rays will go. Incident rays will go like this. Incident rays will go like this. So this is the positive side. This is the negative side. That side is positive. This side is negative. Yes or no? So hence, what will happen, my dear students? Object distance is basically negative. Image is also on the negative side. Focal point. Remember, the focus will be somewhere here. So hence, the focal length is also going to be negative. Everything negative. Everything is going to be negative. Everybody understood how this has to be done? So one more example just to confirm, double sure that you have understood everything. Just imagine that you have a mirror like this. There is an object over here. Okay, this is an object, and let's say the image is formed over here. Let's say the image is formed over here. Okay, now this is your situation. Think about what the object distance, image distance and focal length will be. Will it be positive or negative? Come on, think carefully. The object is here, image is here. How will the rays come from the object? The rays from the object will come like this, towards your left side. Towards your left side. The direction in which the incident rays go, that side is positive, this side is negative. Yes or no? This is positive, this is negative. So come on, think about it. If this is positive side, if this is positive side and this is negative side, object distance, the object is on the negative side, so object distance is negative. Yes or no? Image is on the positive side, so image distance is positive. Yes or no? Last thing, if this is a convex mirror, obviously the focal point will be somewhere here. The focal point will be somewhere here. That is also on the positive side, so focal length is also positive. That's all. Pakka clear? After this, there should be no ambiguity in the sign convention and how this value of U, V and F are decided. Clear? Perfecto. Perfecto. That's it. Let's move on to some questions. Here we have a fill in the blank question. There is a dentist. Wow. How many of you want to be dentist? I just want to know, curiously. Okay. Uses dash mirror and he places the tooth between dash and dash maybe to see a dash image. What do you think should fill up the blanks? Okay. No problems. 11th class not completed. Gopika, I'll tell you what. If you have not yet completed 11th standard syllabus, I don't know how many of you know this. There is another channel of mine. I know it's a JE channel, but still you can use it. So this is another channel. So if you go to the playlist, it's called as Enlight, or basically Vedantu JE English. I know it's a JE channel and you'll be like, oh my god, is it going to be tough? No, it's up to you. You can revise all the classes. So you can see 11th standard physics classes. 11th standard physics classes is called as the Nurture playlist. Click on this playlist. You can see all my lectures, right from vectors, detailed, everything is there over here till waves. Same thing is there for even 12th standard. So if you go to class 12th physics, Pathfinder, view full playlist. So you will see right from this electrostatics, lecture 1, 2, 3, 4, 5, everything, magnetism, ray optics, modern physics, communication systems, everything is there over here. That's on a different channel, but still you can use that channel as well. It's called as Vedantu JE English. Okay, that's up to you if you want to do it, just in case. Okay, moving on to this one. And oh, great Viju, no problem, even if you're following it there. Okay, so what do you think is the correct answer? Concave, yes, you use a concave mirror and he places the tooth between focus and the pole so that you get a virtual magnified and erect image. So let me just show you the ray diagram for that and then we'll see the actual photograph of that. So imagine this is a concave mirror. Imagine this is a concave mirror. This is your principal axis. So let us just say maybe center of curvature is over here. Maybe your focal length or focal point is somewhere over here. So if you see, this is your pole basically. This is your pole. Okay, so dentist uses a concave mirror. This is a concave mirror, places a tooth between focus and the pole. So imagine you have the tooth, which is basically your object. It is placed over here. This is your object, guys. How will the rays go? So you can do one thing. You can show one of the ray going parallel. One of the ray going parallel. So after the reflection, it will pass through the focus. After the reflection, it will pass through the focus, right? Like this. That is one such ray. Another ray, what you can do is you can make it pass through the center of curvature. It will, after the reflection also, it will pass through the center of curvature, something like this. If the ray goes like that, it will pass again through the center of curvature. So it will go like this. So you can see both these rays are actually diverging rays. So they are basically diverging. They are basically diverging. So you just need to extrapolate this behind. You extend this behind, and you will probably see that they meet somewhere over here. So essentially what happens is you get where they meet. So that is basically your image. This image is obviously going to be virtual because it is behind the mirror. Number one. Number two, it is magnified. You can see object is this much, image is this much. So magnified, and it is also erect. In fact, there is a formula for magnification also. If you want to know that, that also I will give it to you. So the formula for magnification, the formula for magnification, which is M, which is image height upon the object height. Image by object. How many times is the image as compared to the object? 2 times, 3 times, 5 times, 100 times, 0.1 times, that means diminished. That is given by negative V by U. That is also a very important formula. In case you want to remember it, definitely it will be very useful. Okay. Another ray did not pass through F. It's up to me, na? Remember the rules? I just gave you the rules over here. These rules can be used anyhow. Either use this and this, or this and this, or this and this. So the rules which I have used over here for drawing the ray diagram: 1, a ray parallel to the principal axis passes through the focus. Second, no. Third, yes. Third rule is ray which goes to the center of curvature or appears to go through the center of curvature will also pass through the center of curvature after reversing or after reflection. So the ray was going here, it reflected back and came back to the same point. Is that okay? Make sense? M is not V by U, M is minus V by U, Siva. That negative sign is very important. So how does it actually look like? It looks like this. Look at this. This is a concave mirror. This is your tooth. The tooth is between the focus and the pole. So your pole, the pole will be somewhere here. This is where the pole of that mirror will be. The focus might be somewhere over here. This tooth is basically your object. The image is formed over here. I hope that makes sense to all of you. Did you enjoy this now? Did you understand this now? Compare this diagram, just tilt it like this with this diagram. So object is placed between the focus and the pole. The image is formed behind. So you can see from here, oh, the tooth, this has cavity here. Oh, there is a gap here. Oh, this tooth is crooked. That's how it is. Everyone? All right, all right. So nobody wants to become a dentist, okay? My friend also like me only, sir, but scored 90% in by preparing only 2 months. Definitely it is possible, bacha, like I told. Examples are always there. Okay, what about this question? If image is inverted, it will be bad. So that's why the image is erect, that is clear. So you know you are not confusing with left and right, or else the doctor thinks the tooth is like this, but it is actually like this. No, it's erect only. An object is placed on the principal axis. Radius of curvature given. Distance 10 centimeter. Find the location and the nature of the image. Let's see how many of you can do this within 30 seconds. I'm going to give you 30 seconds. I'm going to start a timer right over here. Even if you're watching it recorded, I want you to probably do it. Okay, I'll give you 1 minute, guys. Come on, chalo. 1 minute I'm giving it to you. Within 1 minute, try to do this question, answer the correct one. Object is in front of a convex mirror. Radius of curvature 60 centimeter. Distance of the object 10 centimeter from the pole. How will the image be? Where will the image be? Real, virtual, 20, 40, whatever you want. Sampath wants to be. Come on, come on, come on. Let's see how many of you can do this. 33 seconds left. 9, 8, 7, 6, 5, 4, 3, 2, 1, and time is up. So let's have a look. The correct answer to this question is option A, my dear students. Okay, like you can see over here. First of all, it's a convex mirror. Be careful. It's a convex mirror. Object is placed over here. What distance is it placed? It is clearly mentioned, 10 centimeters. Obviously, the focal point will be somewhere over here. Now, you can see the rays of light will come like this. So this is the positive side, this is the negative side. So starting by writing all the values which I know, object distance is on the negative side, so minus 10 centimeters. Radius of curvature is magnitude wise 60 centimeters, which is basically 2 times of f magnitude wise. So the magnitude of the focal length will be 30 centimeters, but sign wise it is still plus 30 only, because focal point is on the positive side. So luckily for us, focal length is also positive. Now you just have to use the mirror formula. Mirror formula says 1 by v plus 1 by u is equal to 1 by f. V value I do not know. Object distance is nothing but minus 10 is equal to 1 by focal length, which is basically 30. Everyone with me? Okay, so let's try to do this. So 1 by v will be nothing but 1 by 30 plus 1 by 10. Now I know what happens over here. I can take the LCM to be 30. So this will remain 1 only, and this will be 1 plus 3, right? This is what it's going to be. So that is going to be 1 by v, right? Is going to be, yes, radius of curvature. Yep, everything is fine over here. Yep. Now what happens next? This will be 1 plus 3 is nothing but 4. So this will be 4 by 30, which is nothing but 2 by 15. I don't see any option matching over here. Why is it not matching? Because I'm getting 1 by v as 15 by 2. So v is basically 7.5 centimeters. So I'm getting v as 7.5 centimeters. I think the options mentioned over here are wrong. Let's see if I've done everything correctly. U is minus 10. Perfect. Yep. Object is placed at a distance of 10 centimeter. R is 2f, 60 centimeters. Perfect. Focal length is 30. Perfect. Plus 30, that too. 1 by v plus 1 by u is equal to 1 by f. 1 by f is 30. Yes. Minus goes over there, becomes plus 10. 1 plus 3, 4. Everything is fine. So I think the answer given over here is wrong. Yep. So this is plus 7.5. So that means the image is formed on the positive side. So it's going to be over here. So the image is going to be formed over here. So this image will be basically virtual in nature because it is behind the mirror. It is behind the mirror. So obviously it is going to be virtual. You are seeing it behind the mirror. So it's a virtual image of 7.5 centimeters. So it is none of these. I think the options mentioned over here are wrong, or maybe the values were different and the options have been pasted from somewhere else. So, but this is the answer. Okay. Now there is one more question, but this question you're going to solve it on your own and post the answers maybe in the chat section or in the comment section. Why? Because after this I'm going to give you a break now. Answer and the solution will be provided to you as a PDF in the Telegram channel. So how about a 10-minute break, a short 10-minute break, guys, and we'll meet after 10 minutes. Okay, we'll meet after 10 minutes and then we'll continue with refraction. Okay, we're going to start with refraction. Everybody be back. Okay, 10 minutes I'm giving you, and if you want, you can even solve the homework question. All right. Alright, we are back. I hope you guys can hear me and see me. Thank you for loving the session, Pooja, and looks like you are able to understand everything. Great, let's move forward. Interesting session, says Ashrita. Siva, whole session PDF will be sent. Yes, Siva, definitely. Jay had a Kit Kat, I guess. Janvi, I don't know what the answer is, but I'll keep it a secret because it's going to be posted in the PDF. You're really missing my classes in my class. All my faculties like you, only from different states. Really, I mean, they're missing them. It looks like you only. Oh, is it? Probably you should send me a picture, or you should probably send me a private message on this Instagram handle, Captain_Shreyas. Maybe you can tell me which classes you're in. Perfecto, great. Natarajan saying 20. I don't know. I'll post the answers in the Telegram channel. Let's move. What are we going to see now? Refraction. So refraction is also a very important topic. Refraction means, bending of light. When light goes from one medium to other medium, many things change, or the characteristics of the light change, some of them at least, and that's what we're going to see. Good example is when you pour water in a container, suddenly the surface appears different. If there is an object immersed inside the liquid, it looks at a different place than where it is actually supposed to be. So that bending of light, which happens when the medium changes, when the light travels from one medium to another medium, that phenomena is called as refraction. Like you can see over here that there is a glass-like object. The light ray is coming from this side. As you change the angle at which the object is placed, you will see the amount of bending also changes. So it not only depends on the medium, but also depends on what angle are you making that light fall or incident on the other surface or the other medium. So the amount of bending depends on the medium as well as the angle of incidences. So that is basically called as refraction. That is your section 9.3 of your NCERT. Great. Let's move on. Now, let's see if you guys can answer this question, and maybe then we can move ahead. What happens when the light is refracted into a medium? Do you think the frequency and the wavelength of the light increases? Or do you think the wavelength increases but the frequency remains unchanged? Or wavelength and frequency both decrease? The wavelength decreases but the frequency remains constant. What do you think really happens? Okay. When I say light goes from one medium, let's say air, into another medium. So light goes into some other medium. Refracts means it changes the medium. Let's say it's going from air into water or glass. What do you think will happen? Frequency, wavelength, what changes? Yes, this is for board exam also. Sachin is always rocking, the captain is always rocking, students are always rocking. Everyone is rocking, always. Okay, many of you are saying D, but the correct answer is B. The wavelength increases, but the frequency remains unchanged. So I'll explain you the reason, okay. So whenever medium changes, it's the speed of light which changes. Keep this in mind. So let me just put it up over here for all of you. Speed of light, C. Speed of light, basically. This speed of light is wavelength into frequency. It's a wavelength. Standard wave speed is wavelength into the frequency. Standard formula. Now the moment you go from a rare medium like air to a dense medium like water or glass, the speed of light will go down. Speed of light will go down. Speed decreases. So you might wonder, sir, if speed decreases, will wavelength decrease or the frequency decrease? Because both, if LHS decreases, both RHS also and LHS should decrease. The answer to that is, frequency never changes because frequency completely depends on the vibrations. If it is vibrating like this, when it goes to the other medium also, it vibrates at the same frequency. Frequency depends on the source. The source created that frequency, the same ripple effect, the same vibrations, frequency will be transferred. So what happens is, my dear students, that the frequency always remains constant. It always remains constant. So because of that, what will happen is the wavelength will have to reduce. The wavelength will have to reduce if speed of light decreases. The exact reverse is also true. If the speed of light increases, then the wavelength will also increase, but frequency will remain constant. Everyone with me? Everyone with me? Understood? I'm so glad Dog Brain Sculpture. Nice name you have, at least the handle. and more than biology you are loving physics. Oh my god, what else I want? I'm feeling so confident, I feel like a pro. I'm so glad, bacha, you're feeling like that. That is the happiest feeling that I can probably get as a teacher, and when a student says that especially. Thank you so much. Okay, so everyone clear? Frequency depends on source. Speed depends on the medium. Wavelength, bechara, is decided at the end. It will ask source, what is the frequency? Okay. Medium, okay, you are this medium, this is the speed. Okay, wavelength is like, okay, this is the speed, this is the frequency, okay, this is my wavelength. So wavelength is always calculated in the end, keep that in mind. Now, not just the speed, but also the angles change, like I told you. If you make the light fall at an angle, the angle at which it bends depends not only on the medium, but also on this angle of incidence. That brings us to the laws of refraction. Laws of refraction. First law is very simple. The incident ray, the ray which is falling on to some surface, the perpendicular drawn, which is also called normal, and the ray which bends, which is also called as the refracted ray, incident, perpendicular, normal, and the ray which is bending, which is refracted, all three of them are in the same plane. That is the first simple law of refraction. That's number one. They lie in the same plane. The second one is more important. The product of sine of incident angle into the refractive index is a constant. Or you can just say the ratio of the sines of incident and refracted angles is constant. What do I mean by that? I will explain that to you with a diagram. The sine of incident angle means a constant ratio with the sine of refraction. I'll just explain that to you, but before that, remember, refractive index is a property of the medium. Like you have coefficient of friction, tells you how rough the surface is, density of a medium, which tells you how much mass is concentrated per unit volume, right? So there are different properties of a medium. Same way, refractive index is also an experimental property. You cannot derive it. It is always experimental. You calculate it. It tells you how dense that medium is optically. If refractive index is higher, it is dense, that means speed of light will be slow. Rarest of the rarest medium is vacuum. Nothing is there in it. The refractive index is 1, unity. Nothing can have refractive index less than 1. 1 is the smallest refractive index, that is basically vacuum. Air has refractive index of 1.00 something, 00029. So, you know, it's in the decimals, but very close to 1, because air is as good as vacuum. Hardly anything is there. When you go to water, it is like 1.33. It's slightly higher. When you go to glass, it is 1.5. When you go to diamond, it is 2.4. So refractive index tells you how optically dense it is. Higher the refractive index, slower the speed of light. Higher the optical index, refractive index, slower, or the light speed will decrease, and the light will bend even more. So that's why you will see when the light goes from rare medium like air to dense medium like water, the light bends towards the normal. But if the light goes from a dense medium like water to a rare medium like air, it bends away from the normal. Is that okay? So rare to dense, it bends towards, speed reduces. So I can mention everything over here. It bends towards the normal, bends towards the normal. Speed reduces, speed of the light also reduces. Frequency will never change, remember that. And even the wavelength also reduces, because speed reduces, wavelength reduces. Keep this in mind. Here it is exactly opposite. Here it bends away from the normal, bends away from the normal, obviously. Here the speed increases, frequency does not change, but the wavelength will also increase. That's how it is. I'll not invite you to my marriage function, bacha, because I'm already married, Gopika. Okay, but maybe I can invite you to some party, okay, where all of us are going to celebrate your victory when you guys, are going to get into beautiful colleges, and I'm going to party with all of you. Yes. Okay. And all the best, Chimki Rockstar, for your physics board exam. Now let's talk more about refractive indices. Okay, let's talk about it. How do I define refractive index and what is that Snell's law exactly? Observe carefully. If light goes from medium 1 to medium 2, this is medium 1 to medium 2. This is how the light is traveling. Okay, so maybe I can just show a rough diagram like this. You can just show a rough diagram. This is your normal, and light is coming from this medium, making angle, let's say I. It is going into another medium, making angle R. Okay, so in such a case, here is what I'm going to write. Refractive index is a constant, and it is written down like this: mu1, which is the refractive index of medium 1, okay, into sine of angle made by the ray with the normal, in this case it is I, is equal to mu2, refractive index of the second medium, into sine of the angle made by the ray in the second medium, in this case it is R. That's all. This is nothing but your Snell's law. So you can just write it as sine of I by sine of R is, sine of I by sine of R is mu2 by mu1, which is also called as 1 mu2, because light is going from medium 1 to medium 2, 1 to 2. It is called as refractive index of 2 with respect to 1. Refractive index of this guy with respect to 1, not 1 with respect to 2. Be careful. Okay, I hope this is clear. Gopika, you can find it on Instagram. It's already there. You'll see videos also. Okay, great. Everyone with me on this? 1 mu2 is nothing but when light goes from medium 1 to medium 2, that is called as refractive index of 2 with respect to 1. That's one thing. Next important thing, you can also write this as sine of I by sine of R, which is 1 mu2. It is also reciprocal of this, so it is nothing but 2 mu1. Yes, it's perfectly fine. There is no harm in writing it this way. Not just that, you can also write this entire equation in this form, where you write 1 mu2, okay, 1 mu2, which is mu2 by v1, is also speed of light in the first medium upon speed of light in the second medium. Speed of light is frequency into wavelength. This is also frequency into wavelength. Frequency cancels, so it is lambda 1 by lambda 2. So you can write it in terms of wavelength. You can write it as a reciprocal, invert the relation, or you can also write it as ratio of the signs. All these are nothing but Snell's law in different ways. Different ways. That's all. Okay. One last thing before we go ahead. Guys. Remember, there is a chain rule. There is a chain rule also in case of refractive indices like this. If I have A refractive index B, okay, or B's refractive index with respect to A, if I multiply it with whatever is the last alphabet, I write it the first, then I use some other alphabet like C, then I multiply it with another refractive index. The second alphabet was C, right? So I put C first and then I put D. Then you can see B is common. Whatever I end with, I start it with that. Whatever I end, I start it with that. Then the product of all these three refractive indices will be, the first alphabet was A, the last alphabet was D. That's it. So this is basically like a chain rule. You can see there is a chain formed, B to C, C to D, and so on and so forth. Then A's refractive index and D's refractive index relatively with respect to each other is just the product of these three refractive indices. Okay, if this is clear, then we'll also go ahead. So I'm just blocking this formula for all of you. Very easy to remember. A with B, B with C, C with D, then A with D is just the product. Okay, now what are the typical refractive indices? Let me just give you some value. Refractive index of vacuum is 1, okay, which is also closely refractive index of air. Most of the times you take it as 1 only because 1.000 29 is roughly 1. Refractive index of water, you approximately take it as 4/3. Refractive index of glass, you take it as 3/2 or 1.5. And you will see refractive index will be anywhere between 1 to 3. So very high refractive index means 4 or 5, very specialized material, but generally 1 to 2, 3, max to max 2.5 you will see for most of the materials around you. But there is no upper limit to it. It is very difficult to make such a dense material. Remember that. Is that okay? Everyone with me? Pooja, I think I have answered that question. Where does the value of refractive index lie? Okay, I hope that is clear. Alright, I think we can do some questions based on this now. Here is a question. If the refractive index of A with B is 1.5, B with C is 2, then the refractive index of A with respect to C is how much? Come on, everybody should be able to do this. Is solving PYQs and book questions enough to score 90 plus in boards? Solving PYQs and book questions, that means NCERT books and your class notes and previous year board papers, will it be enough? 90 plus, I think it should be enough, bacha. That's all is needed. But you need to practice it again and again. That's all. Great. Okay, let's see. Asta is saying 3. Let's try to figure out what the correct answer should be. Refractive index of A with respect to B. That means refractive index of A with respect to B is 1.5. Refractive index of B with respect to C. Refractive index of B with respect to C. See how I am writing it. Is nothing but 2. The question says, what is the refractive index of A with respect to C? Refractive index of A with respect to C. How can I write this? Think about it. CA, right? Oh, I know what to do. Mu and then C and A using chain rule is mu. The first alphabet is C. Let me put the second alphabet as B. Okay? Into mu. I end it with B. So I start with B. And finally I end it with A. Obviously this is chain rule. B is common. So the first and the last alphabets are C and A. I just put it over here. Correct? Okay. So is mu CB known? Yes, mu CB is basically 2 multiplied by mu BA. Yes, that is also known. That is 1.5. So 2 into 1.5, 3/2. That's going to be 3, guys. That's the final answer. Where is it? Option B, of course. Very good. Many of you gave the correct answer, starting with Asta, Sampath, Ashrita, so many of you. Cauchy law, whatever you want to call it. I call it the chain rule. You can give it whatever fancy name you wanted. Sampath, Nishant, very good. Siva, Pooja, very good. Chimki, very good. Excellent, Chimki. I guess you said okay for some other reason. Okay, so now that you understand how refractive indices are related with each other, with speed of light and all of that, how about taking it a step further? You know what? When light goes from rare to dense, there is no problem. But when dense to rare happens, there is a problem. I'll tell you why. Look at this diagram. Probably things will be very clear. When it is going from rare to dense, if I make the ray fall like this, it will go like that. If I make the ray fall like this, it will go like that. If I make the ray fall like this, it will go like that. So I have multiple options of making the light fall at different angles of incidence. The same is not true for the reverse case, when it goes from dense to rare. If the light goes like this, it will come out like this. If the light goes like this, it will go away. If the light goes like this, it will go here. But maybe there comes a point after which when I make the light fall or incident, it's not able to bend away further, because if it bends further away, it will come back into the same medium. It is not going into the other medium because the light is bending away, right? So there is a limit till which the angle of incidence can be increased. So that brings us to the concept of total internal reflection. And this concept is also used in optical fibers. So when light is coming from a dense, like glass, to air, there is a good chance that it might get internally reflected. Like you can see over here, the laser light right now is passing through the glass tube. But if you make it fall at a certain angle, you can see it is getting reflected within the tube. It is not getting refracted, it is getting reflected. So that happens in some special conditions. Now, the concept of total internal reflection is so important that there are so many times in NEET, in your boards, so many questions or just derivations just come over there. So let me just show that to you. Okay, very easy. So here is what I'm going to draw. I'm going to show a dense medium. Just look at the way I'm going to show it. This is a rare medium. This is a rare medium. Let me just probably draw the normal to it. This is nothing but the normal. Okay. Now, if I make the light fall, at an angle like this, it's going to come over here. This is the angle of incidence, it's bending away. So it's a rarer medium, so that's why it's going away. It's coming out beautifully. Perfect, no problem at all. Then I make the light fall at a slightly higher angle. Oops, 1 second. Let me show straight lines. Let me show it at a higher angle. Okay, then it will even bend further. It comes out like this. I hope you guys can see it. Light green to slightly darker green. Now what happens is that I make the light fall at such an angle over here that the light ray is almost grazing that surface. This is called as grazing reflection. Almost it makes 90 degrees. This is my critical angle. This is my critical angle. Okay, keep this in mind. Because what happens is, after this angle of incidence, even if you try to make that light fall at this particular angle, you will see that it will not be able to come out. In fact, it will just get reflected. This is total internal reflection. TIR, total internal reflection. It will follow the laws of reflection only, not refraction, not Snell's law. Laws of reflection, angle of incidence is angle of reflection. That's it. If you make the light fall at some other angle higher than this also, no problem. It's just going to get reflected internally. So this is total internal reflection. So if the angle is less than the angle of critical angle, then the light refracts. If the angle is more than or equal to the critical angle, then you will see it will get internally reflected. Grazing means almost parallel to the surface. So at critical angle, the angle of incidence is very close to the critical angle, or I can just call it as IC, and the angle of reflection is almost like 90 degrees. So using our Snell's law, you will see nothing but sine of I by sine of R. Sine of I by sine of R, be careful. Here what I am going to put, sine of I and sine of R. Remember, sine I when it comes, I should, or I'll just put it this way because I've been doing it like that. So sine of I into refractive index of the denser medium is equal to sine of R into refractive index of the rarer medium. So now I can just say sine of critical angle into refractive index of denser medium. Sine of R, that means sine of 90 degrees into refractive index of rarer medium. So now what I'm going to do is I'm just going to write it as sine of IC divided by sine 90 is 1. This will be nothing but mu R by mu D. Mu R by mu D. What is it? What is mu R by mu D? Guys, it is nothing but the refractive index of the rarer medium with respect to the denser medium. Mu RD, right? I just gave you this formula right over here if you forgot. Mu 2 by mu 1 is 1 mu 2. Mu 2 by mu 1 is 1 mu 2. That's how you write it. So over here also you can see mu R by mu D is mu dr or mu RD. That's all over here, correct? But generally you do not give the refractive index of rare medium with respect to dense medium. You generally give the refractive index of the dense medium with respect to the rare medium. So that is why I will write it as 1 by refractive index of the dense medium with respect to the rare medium. This is sine of that critical angle. Now this becomes my important formula. This becomes my important formula. If you know the refractive index, like for glass or for water or some liquid, reciprocal of that will be the sine of the critical angle. That's all. How sine 90 comes? Because R is 90, no? Do you see angle of refraction is 90 degree? This is normal, this is refracted ray. So it is 90 degree. So that's why R is taken as 90 degree. Is that okay? Yes, angle should be always measured from the normal. Yes, yes, it is 90 degree. It is, a lot of people think, oh sir, it is coming here, so angle should be 0. No, no, it is 90 degree. I hope this is clear. Yep, very nice, very nice. So is total internal reflection, can it happen in rarer medium? Never, never. It can only happen from dense to rare. Because for rare, no matter which angle you give, it will always come to the other side. Just see that previous diagram. No matter what angle you give, like this, it will come here. Like this, it will come here. Like this, it will come here. Like this, it will come there. So it will always pass, no matter what angle you choose, 0 to 90. But only problem happens for dense to rare. It will not be able to come out for all the angles. Is that okay, bacha log? Done. So many applications are there. Mirages, diamonds, reflection, all of this is because of multiple reflections happening, total internal reflection happening. A diamond shines the way it is because the light is getting internally reflected because of high refractive index. So you will see that it has a very small critical angle because of which the light rays immediately get reflected and so many reflections happen that the diamond shines. Mirages, you might have seen this in desert. It feels like there is water here. This water is actually not there. What is happening is the rays of light coming from the sky is getting reflected because of different layers of the atmosphere, and you feel as if the rays of light are coming from below, but actually they are coming from the top, bending and coming into your eyes. But you feel as if it is coming from the ground. You feel the sky's blue color is there below, so you find it like the water or a lake or a sea or ocean. So that is confusing, but actually it is not coming from there. So these are some applications of total internal reflection. Sir, will reflected ray is taken as the TIR ray? Yes, the reflected ray is the totally internally reflected ray. Yes, total internal, the red and the orange ones in this case. The blue and the green ones are not internally reflected, they are still going outside. Yes, water which you can never reach, very true. Okay, now you will also see many more applications in case of optical fiber. I just showed it to you over here only. This was a very good application. So your broadband, your internet which is coming into your houses, most of the times it is through such a cable. The main service center or whatever data center will be sending light rays through an optical fiber, and the light rays keep on getting internally reflected, so they cannot go outside, and that's how you get the data at lightning fast speeds into your home. So it's an optical fiber network. So there is total internal reflection concept used. Even you can use the concept of total internal reflection in prism. We'll be solving a problem on it after some time. Okay, don't worry. Let's see if you can solve this question. When a ray is refracted from one medium to another, the wavelength changes from 6000 to 4000 Armstrong. What do you think is the critical angle of that particular medium? Sivasankar, I am not tired. 2 hours crossed. Oh my god, I don't even realize. But I am fully energetic. We are just halfway through the chapter, I guess, or little bit more than half. Come on, let's see if you guys can figure this question out. Light goes from one medium to other medium. What do you think is the critical angle of that medium or that surface? See, when wavelength changes, medium changes and speed changes. That means refractive index can be found. So the refractive index is nothing but speed of light in one medium upon speed of light in other medium, which is also f into lambda 1 upon f into lambda 2. We all know the value of frequency is same, so it will get cancelled. So lambda 1 and lambda 2, I know that. Lambda 1 is 6000, lambda 2 is 4000. 0, 0, 0 cancel, 6 by 4 is 3 by 2. Oh, the refractive index of the dense medium is 3 by 2 with respect to the rare medium. Now we all know the formula for the critical angle. Sine of the critical angle is 1 by mu of the dense medium with respect to rare medium. So this will become 1 by 3 by 2, which is basically 2 by 3. So sine of that critical angle is 2 by 3. Sine of that critical angle is 2 by 3. So therefore the critical angle will be, take the sine on the other side. So it will become sine inverse of 2 by 3. That's all. That's your final answer. Where is that option? Sarvana has already said it. 2 by 3 sine inverse, option C. Very good, Ashrita, Nishant. Yes, Shiva, Sarvana. Awesome, awesome. Today's concept is awesome. Very good acing. Great. So this is how you can mix and match concepts of critical angle with wavelength also, or speed of light also. All these things can be done. So I hope you guys understood what is critical angle and how the problems are solved. Now there is another phenomena related to your refraction, and that is your apparent height and apparent depth. So you might have seen sometimes when a swimming pool is cleaned and they drain out all the water, the pool appears suddenly very large and you're like, oh my god, the swimming pool was so big. But when the water is full, then you find, oh, the flooring is very close. You see the floor coming up. So what happens is the concept of apparent depth over here. So what is deep appears shallow when you are looking at it from outside. Look at this girl, she is seeing this diver inside. The diver appears closer to the surface, shallower. This is only because of refraction. The rays of light coming from the object inside that dense liquid, they bend away from the normal because you are going from dense to rare. So they bend away. So it feels as if when the rays are entering the eye of a person outside, if you extend it backwards, it's coming from here. So because the ray is bent like this, it feels it is coming from here, but actually the person is here, because you can see how the ray is going like this. So if you extend it backwards, it feels it's coming from here. So you feel it is little bit above. Everyone fine? Now the exact reverse happens if you are in the dense and looking at a person outside. If you are in the dense and looking at a person outside, okay, very interesting thing happens. So if this ray enters the medium, it will bend like this and enter the eye of the human here. This human here will extrapolate, will extend this ray behind. It will feel, or he will feel, or she will feel that the ray is coming from here. The ray is coming from here. The light has bent towards the normal because it's dense. So you will feel that that person is away from the surface. So the apparent height will be higher, taller, farther. So when you are a bird looking at a fish, the fish appears closer. But if you are a fish looking at a bird, the bird appears far away. So for the bird, the fish appears closer. For the fish, the bird appears farther. That's the trick to remember it. That's all. How that is dense to rare, sir? Because which one? You are talking about the first case or the second case? See, the first case, when this is the observer and this is the object, then the ray of light coming from here is going to this medium because eye is here, the observer is here. So the ray will go from dense to rare. Image will be formed here. When the observer is here, object is here, the ray from the object will bend from rare to dense. So the image will be formed over here. I hope that is clear, Satya. Okay, you can repeat it once more by yourself. You will get the answer. Now the formula is also very important. Observe this. If the observer, so I'm showing an eye just to show you where the observer is. The observer is in the rare medium, but the object is in the dense medium. So this is where the object is. This is where the object is. And let's say the object is at a depth of h0. Is at a depth of h0. The image will be formed. The image will be formed little bit closer. The image will be formed little bit closer. This depth is basically your apparent depth. This is your apparent depth. And this apparent depth is actual depth by the refractive index. Actual depth by your refractive index. That's all. That's the formula. And the exact reverse is also true. Imagine if the observer is in the dense medium. The observer is in the dense medium. But, and that means you're a fish, and you're looking at a bird which is in the rare medium. So just imagine that the object is somewhere over here. This is my actual height. This is my actual height at which the object is. The object will appear a little bit farther over here. This is where the image will be formed. And this height, which is the apparent height, Instead of dividing, you are going to multiply it with mu. So it is refractive index into the actual height. So when you multiply, obviously it will become longer because mu is more than 1. So you will see it farther. When you see it closer, you divide it by a number more than 1, which is mu. So it will be closer. Is that okay? Everyone, is this difference clear? So these are two important formulas. This is formula number 1 and this is formula number 2. Both the cases have been discussed now. Write it down in your books, write it down in your notes if it was not there. Let's see if you can solve this question. I want everybody putting it up. Bird and fish problem. A fish is 9 meters above the surface of water and the fish is, I think the bird. I think this should be the bird, not the fish. And I'm sort of wondering why is the fish above. This is the bird which is 9 meters above the surface of water and the fish is 4 meters below the surface of water. The apparent position of the bird and the fish seen by the other is how much? Come on, everyone post the answers in the chat box ASAP. Everyone post the answers in the chat box ASAP. If you're watching it recorded, work it out. I'll give you 20-30 seconds. First of all, if bird is the observer, okay, then what will happen? Fish will be closer. Fish is obviously closer. So the depth that we are talking, the apparent depth will be the actual depth divided by mu. So then it will become small. Actual depth is how much? It is 4 meters below. Refractive index, what is it? Water, right? So water's refractive index is 4 by 3. 4 cancels, it will be 3 meters. So that is the first answer. This is the new depth. This is the new depth. So it appears at 3 meters. Actually, it is at 4 meters. The reverse case, if the fish is the observer, and basically what you are going to see is the bird is far away. The bird appears to be far away. So the apparent height will be mu times of the actual height. Mu is 4 by 3. The height is how much? 9 meters. So 9 meters. 9 by 3 is 3. 3 4s are 12. So 12 meters. Actually it is 9, but it appears at 12. That's it. Very good, Sarvana. Yep. So see if you made some mistake, Ashrita. The answer should be 3 meters and 12 meters. This is height. Okay, so that's how you solve these questions. Very simple. One place you divide by mu and it is close. When it is far, you multiply by mu. That's it. That's all that is there in apparent depth and apparent shift. That's all. Now, there is one more concept. Yes, one more concept. Yes, Sampath, very good. That's the correct answer. One more concept of refraction through a glass slab. And you would have done this experiment 99% in your school life, where you take some pins on the board, you take a glass slab and see where the pins are from the other side of the glass slab. So if a ray of light is going like this, what happens is, my dear students, if you draw a normal here, this becomes the angle of incidence. This becomes the angle of incidence. This becomes the angle of refraction. This becomes the angle of refraction. On the other side, if you draw a normal, won't this normal and this normal be parallel, because this is a glass slab? So all surfaces are parallel, so their perpendiculars will also be parallel. So if this is R, even this is also R, right? If this is R, this is also R, because these two lines are parallel, correct? Now the next thing is, if this is R, then what will this angle be? Obviously, if incident angle was I, refracted angle is R. Refracted angle is R, incident angle will be I. Reversibility principle. So this angle will be I. That's all. So whatever angle at which it came in, the same angle it will go out. That means this ray and this ray are parallel to each other. So this ray, after deviating, it deviates again. It is parallel to the incident ray. But if you extend it, you will notice it has shifted by some amount. I hope you guys can see that shift over here. That shift which is happening over here. This is called as the lateral shift. What is it called? Lateral shift. It shifts parallelly, that's why lateral shift. As simple as that. So the concept over here is that the angle of incidence is equal to the angle of emergence, number one. Angle of incidence is equal to angle of emergence. The second important thing is the amount of the lateral shift is given by the thickness of the slab into sine of I minus r by cos of r. This is a standard formula. They haven't asked any question on this till now, so I doubt they will ask any question, but still I am giving it to you. What is this T? T is nothing but the thickness, not the time. This is how much is the thickness of that slab. How much is the thickness of that slab? That is basically your T, the thickness of that slab. I minus r upon cos of r. That's all. These are the two important formulas. First is angle of incidence is angle of emergence. That's what I have shown over here. There is a shift over here that is called as a lateral shift. That lateral shift is thickness into sine of I minus r upon cos of r. That's all. That's something which you should know. Okay. Now let's move. No, Ashrita, that is different. That is t into 1 minus 1 by mu. That is for different case. So let me tell you that also. That is for just a slab. See, don't get confused that with this. If you have a slab of thickness t and you see some object over here, you see some object over here, let's say this slab has a thickness t, refractive index is mu, thickness is t, then the object will come closer. You will see the object over here. That is when the observer is like this over here. This is based on the concept of apparent depth and height. That shift which happens, this shift which is bringing the object closer to you when you see through a glass slab, that is thickness into 1 minus 1 by mu. This comes from this only. From this only it comes. So be careful. That is for a completely different thing. For J Advanced, this will be too simple, Sarvana, but this will be like more like a foundation. Okay. Should we use refractive index of observer in fish and bird problem? No. That is basically the outside refractive index Harni was 1. So the absolute refractive index becomes the relative refractive index. Yeah, it comes from h minus h naught or h naught minus h, whichever is bigger. Okay, Siva? So it's the same thing. Just rewrite the equation, you will get this. So this is completely different. This is for when you see an object through a glass slab, it appears closer. But a ray of light shifts. Ray of light itself shifts. That is called as lateral shift. So many students get confused in this. Okay. So anyways, this is not there so much in NEET. I'm just giving it to you. Okay. Now moving on to lenses. I'll move on to lenses and curved surface. So we have done flat surface. Now curved surface. The best example of your curved surface refraction is lens, camera lens, alright? Or even your eye is a curved surface. When the light ray enters your eye, it refracts, and at every place the angle of incidence is different because the surface of eye or the surface of lens is curved. So the way or the manner in which the rays bend and form the image is very interesting. So if you have a curved surface of some radius, where there is some center, some radius, if you place an object, the image will be formed based on a formula. And that formula is mu2 by v minus mu1 by u is mu2 minus mu1 by r. What is this all variables? First of all, v is nothing but where the image is formed. This is basically your image. So this is your image distance. This is your curved surface. You can see this curved surface. You can also probably see that this is your radius of curvature. So same radius I am showing over here. And here is the center of curvature. So curved surface, radius of curvature, center of curvature. V is where the image is formed. O is nothing but your object distance. U is basically your object distance, O is the object. So this is your object. So this is your object distance. This is your object distance. How far is the object from the pole? That's U. V, standard. How far is the image from the pole? R, radius of curvature. What is this mu2 and mu1? So guys, very simple. Image distance, right? Image is placed in this medium. So that is the refractive index of the medium where the refracted ray is. Refracted ray where the image is formed. So mu1 and mu2, like you can see over here, these are nothing but refractive indices of the mediums on both sides of curved surface. There is one medium here, another medium there. Object is in medium 1, so U, object with mu1. Image is here, refracted ray is here. So guys, it is mu2. That's all. That's it. I hope this is very, very clear. Lens maker will come to that. Hold on. Okay. Very rarely they ask questions on this. Usually the questions from this formula, they generally ask in J, not so much in NEET. That's what I have seen. But still, let's see a problem which can be asked maybe in NEET. Let's see if you guys can solve this. Imagine there is a ray which goes like that, hits the curved surface, goes into another medium, hits another surface, goes into third medium. Another ray comes like this, goes into second medium and then third medium like this. Can you tell me which one is more, which one is less? Can you tell me which refractive index is more, which refractive index is less? Come on, my dear students, figure this out. Not that difficult. Just draw a normal. I think you will figure out everything. There is a normal drawn here, and maybe I'll just show a normal drawn over here. Maybe you can figure out most of the things. Come on. And same thing, you can probably draw a normal over here as well. If you draw a normal here, probably it just looks like that. So now you should be able to figure out, guys, which one is more, which one is less. This angle is more. It has bent towards the normal. So definitely mu2 is stronger, denser than mu1. That's one thing. And mu3, you can see it's bending even closer. If you compare this angle and this angle, this ray has bent even closer towards the normal. So mu3 is even more dense. So mu3 is more than mu2 and mu2 is more than mu1. As simple as that. Very good. Perfect, Sarvana. How about these three? I find there is no bending, deviation itself happening from 1 to 2. It's going straight as if it's the same medium. So definitely mu1 and mu2, n1 or n2 are same. But over here, if you notice, this is the angle of incidence, this is the angle of refraction. Here it is more, here it is bending towards the normal. That means it is going to dense medium. So mu3 is higher. So this is less than mu3, or mu3 is more than mu1 or mu2 both. Exactly, Sivasankar. Perfect. This is how some of the questions can be on the curved surface refraction. Now, when you have two curved surfaces together, that becomes a lens. When you have two curved surfaces together, it's nothing but a lens, nothing else. That's all. Concave. Cave means scoop out. So when there is a depression inside, it's like this. It's a concave lens. Usually the symbol for a concave lens is something like this. For a convex lens, it bulges out. So usually you will see this is the symbol for a convex lens. Concave, convex. Simple. Everyone with me? Perfect. Okay. Now, offline classes, I wish I take bacha, but I'm not taking offline classes. But I'll tell you how you can get my classes in different ways. Probably you can contact me on Instagram. All right. Or leave a comment. Now, here, it's exactly opposite behavior of mirror. Remember concave mirror, if the rays were parallel, they used to meet. For convex mirror, if the rays were parallel, they used to diverge. Here it's exactly opposite. Look, if it's a concave lens, then it diverges. Convex lens, it converges. Your magnifying glass that you use, it's a converging glass, convex lens. The rays will meet at a point. You can see this practical demonstration with laser light also. If you use a convex lens, it meets. Concave lens, it diverges. Now, I want to know from you whether the focal length is positive or negative for concave and convex lenses. Let's see how many of you can write this up really quick. For a convex lens, the focal length is positive or negative. For concave lens, the focal length is positive or negative. Using your sign convention. Come on, my dear students. Hello, Sujata. Hello, Rahul. For convex, the rays meet after the refraction. The rays are going like this. This is the positive side and this is the negative side. So hence the focal length is definitely positive. The convex lens, for convex mirror, it was negative. Okay, keep that in mind. All right. No, sorry, for convex mirror, it was still positive only. All right. For concave lens, what will happen? The rays appear to diverge from this point. This is the negative side. This was positive side. So this is going to be negative. That's all. Very nice. Perfect. Positive, negative, positive, negative. Most of you have answered this correctly. Great. Let's see if you guys can solve this question. We have a question. A convex lens is immersed in a liquid whose refractive index is exactly equal to the refractive index of the lens. Interesting question. What do you think is the focal length? If you can answer this, no, hats off. Perfect. Amazing. Like kudos to all of you. If you take a convex lens, immerse it in a liquid whose refractive index is identical to the refractive index of the lens, what do you think is the new focal length? Focal length will become 0, focal length will become infinite, focal length will reduce but not become 0, remains unchanged. Interesting. If you crack this now, guarantee 700 marks. Or in physics, 170 plus marks. Let's see, who are those kids who are going to get guarantee 170 marks? Come on, I want to know all their names. Everybody, come on, put in an effort. Filling air with air. Yes, that's something like that. What do you think will be the new focal length as compared to the old focal length? So just imagine, earlier this was my lens. So the rays which were coming like this, they used to probably meet here. This was the old lens. Now what I do is I take that lens, right? Now what do? I put it inside a similar medium. Whatever is out is in. Whatever is in is out. There is no change in the refractive index. So if a ray of light enters like this, there is no difference that it finds. Why will it bend? Inside and outside, air, air, water, water, glass, glass, diamond, diamond, glycerin, glycerin, alcohol, alcohol, this chemical, chemical, no change. It will go undeviated like this. So if they are parallel, where do they meet? At infinity. So where do they meet? Infinity. Hence the answer is option B. They do not become 0. A lot of people think it becomes 0. No, it becomes unchanged. How is it unchanged? Here it was this much. Now it is infinite. It has changed. It has changed to infinity. Hence the answer is B. How many of you answered it correctly? I can see Nishant, Satya answering it correctly. Very good. 170, pakka. Siva, filling air with air. Yes, but you should tell me the option. Okay. Great. Moving on to the next concept, and that is lens maker formula. What does the topic itself tell you? How to make a lens. Now to make a lens, you need to tell me the material. What are you going to fill it with? Also you need to tell me this curvature and this curvature. Curvature, how much curved they are. Together, all these three different things, material, radius of curvature 1, radius of curvature 2, tells me what is the focal length. So, if you give me any lens, the rays of light which are parallel hit the first surface, which produces maybe a center of curvature here, and that gives rise to radius of curvature 1. Whichever surface it hits first, that surface's radius is called R1. It's not left right. It is whichever surface hits first. And then whichever surface it hits later on, that becomes the second surface. So the radius will be called R2. The medium inside will have some refractive index mu. Imagine if this was not a concave lens but a convex lens. Imagine this was basically a convex lens. Then think which is R1, which is R2. If the rays of light are coming like this, okay, parallel light beam, it is hitting this surface first. So R1 will be here. This is R1. Understood why this is R1? Center will be here. This is the first surface. And then this will be the next surface. The surface's radius of curvature will be here because the center will be here. So this will be R2. Everybody understanding it? Got it? Okay. It does not end here. The story does not end here. Now is the sign convention. Let's see if you are able to figure out the signs of R1 and R2 here and R1 and R2 over here. Let's see if you can get it. I will be very proud of you. What is the sign of R1 here? And what is the sign of R2 here? Just tell me that. That's all. Just tell me the sign of R1 here. The light rays are going like this, my dear students. So obviously if the light rays are going like this, this will be the positive side, this will be the negative side. Light rays are going like this will be the positive side, this will be the negative side. Yes or no? Come on, now think, what is R1 then? What is R1? R1 is on the negative side, right? So R1 will be minus. Whereas in this case, you can see R1 is on the positive side, so R1 will be plus. Sir, the ray will meet after the focal length, then in the convex? Yes, the rays will meet at the focal length after refraction. Yes, Siva. Similarly for R2, over here, it is on this side, so it is positive. Here R2 is on left side, so R2 is basically negative. Cool? Let's take one more example so that I know 100% you guys understood it. Imagine I take a plano-convex lens like this. This is your lens like this. Now the rays of light come this way and they meet over here. Plano-convex. It's a plano-convex lens. One side plane, other side convex. That's why plano-convex. Think carefully and tell me which one is R1, which one is R2, what is the sign of each one of them. The first surface where it hits is this one. Correct? First surface, I'm marking it in blue, right? So let me use the same color scheme. So this is the first surface. And the second surface is obviously this one because that's where the rays of light go here. I can easily see the second surface's radius is over here. This is R2. And the rays are going that side. So this side is positive. This side is negative. So clearly R2 is also negative. Yes or no? R2 is also negative. Now comes the challenging part. What about R1? How many of you can tell me what is R1? What is the radius of curvature R1? This is a flat surface. It's a flat surface. What is the radius of curvature 1? For a flat surface, it's a part of such a big circle. It's so big, the circle hardly appears to be bent. It feels like a straight line. That means the radius is infinitely long. So R1 is basically infinity. R1 is basically infinity. So the R is beyond that N. What do you mean by R is beyond that N means? So the ray, no, that R can be anywhere. Depends on the curvature, bacha. Matlab it can be, see, if the surface is bent like this, then radius will become very small. R can go like that also. Depends on the curvature, how curved the surface is. Is that okay? All right, great. So now that you understand it, what is the lens maker formula? It is basically 1 upon focal length is mu minus 1, which is refractive index of the lens with respect to the outside medium, into 1 by first radius minus 1 by second radius of curvature. That's it. That's the formula. 1 by f is mu refractive index of the medium, lens with respect to the medium minus 1, 1 by r1 minus 1 by r2. All these values have to be put with sign convention. With sign convention. Oh, you are saying r by 2 is equal to f. Okay, very good. You asked it. R is equal to 2f. That is only valid for curved mirror reflection. This is refraction, lens. So for that, it is not R is 2f. In fact, 1 by f is mu minus 1, 1 by r1 minus 1 by r2. It depends on the medium also. It's a completely different story for reflection and refraction. Understood? Clear? So a lot of students make that mistake also. Good, you made that mistake here only. You will not repeat it in the actual exam. All right. Let's see if you guys can solve this question then. If a substance is behaving like a convex lens in air and concave in water, what can you conclude from this? Happens, Siva, no problem. Imagine a lens is behaving like convex in air, but suddenly it behaves like concave, okay, in water. Why do you think this could be happening? Think logically. Imagine this is our lens. It is behaving like convex only in air. So if light rays are coming like this, okay, if light rays are coming like this, then it converges. If outside medium is basically air, this is some substance, maybe some kind of a special glass. But the same lens, the moment you put it inside water, what is happening is it behaves like a concave lens. That means the rays are diverging. Why do you think this can happen? Okay, lens topics are always confusing. Now it's clear. Very good, Pooja. Susanta, how R1 is infinity? I'll just come to that. Hold on. Let me just finish this part. Susanta, Ningtojam. Okay, then I'll come to that. This is only possible because what is happening is, in the first case, observe carefully. 1 by f is equal to mu minus 1, 1 by r1 minus 1 by r2. In the first case, glass has more refractive index than air. So mu relative, this is relative mu. This relative mu is basically more than 1. Relative mu is more than 1. But in this case, the sign itself changed. So over here, you will notice the relative refractive index is less than 1. That means the glass is less dense than the medium outside. Because of which, the sign of this quantity changes. If this was positive, it becomes negative. If this was negative, this becomes positive. Did you understand it? Imagine 1.5 minus 1, 0.5. 0.9 minus 1 is minus 0.1. The sign of this guy changes, so the sign of focal length changes. So focal length from here, it goes to here. So sign of the focal length changes. Everybody understands this concept now? So mu minus 1, sign changes. Sign changes. That is why focal length sign also will change. That's why from convex it behaves like concave. Hence, that's the answer. So the refractive index of the material is less than water but more than air. Is less than water but more than air. That's all. Option C. Very good, Sarvana, Sampath, Ashrita, Anush. Perfecto. Perfecto. So the material is less dense than water but more dense than air. Now going back to the previous part, why the radius of curvature is infinity for a flat surface. Think about it. Think about it. Here the radius is small. Okay, this is the curved surface. The radius is only this much. Now I make it like this. The radius will become large. Okay, I make it more flat. The radius will become even large. Now I make it flat. The radius will become infinitely long. It's a part of a big circle. That's the concept. Okay, is that clear, bacha? small curvature, then slowly make it flat, it will become infinite radius of curvature. That's how it is for a plano convex lens. Okay, I hope this is fine and understood. Let me go to the, this one over here. So here I can just say that the refractive index of the glass is more than refractive index of air. But in this case, I can say the refractive index of glass is less than the refractive index of water. So water is highest, glass is medium, air is the least. That's what I'm getting, option C. I hope Dr. Irfan, now you understood it. Thank you, Priya. I drew a normal and figure it out for the last question. No problem, that's also perfect. But this is using the lens maker formula I made you understand, because here glass is dense. So this number is positive, mu is more than 1. In this case, glass is less dense. So that's why relative refractive index is less than 1. So this number will become negative. So on positive it became negative. That means from positive side the focal length shifted to the negative side. So that's why I can say that the focal length has changed the sign. Hence my conclusion. Power of a lens. Yes, I'm coming to some numerical questions also. Yes. Power. How powerful a lens is how much it can converge or diverge. How much it can converge or diverge. So let's see what is the power of a lens. The power of a lens is basically expressed in diopters, and the power is basically 1 by f. That's all. If focal length is in meters, power is in diopters. If a lens has small focal length, look at this. The rays are going like this and they meet right over here. Whereas, look at this one, they meet here. Okay, this has large focal length, hence less power. Hence you will see focal length and power are inversely related to each other. More focal length, less power. Less focal length, more power. So here you can see there is less focal length, but there is more power in that lens. That's all, as simple as that. So power is 1 by f. F is in meters, power is in diopters. Now, talking about the image formula or the lens formula, how do you locate it? It's very similar to the mirror formula, guys, and even the magnification formulas are very similar. So if you want to locate where the image is formed, just like you had the mirror formula, 1 by v plus 1 by u is equal to 1 by f, and the magnification, which was image height by object height, was minus v by u. Here the signs will change, that's all. In mirror it was plus, right? So you put minus. In mirror it was minus v by u, here you put plus v by u. That's it. That's the only change in the formula. Everything else is same. Sign convention, meaning, the manner in which you apply or use it, everything else same. So in mirror it was plus, here it is minus. In mirror this was minus, it is plus in lens. That's all. Awesome. Clear? Okay, everyone. So based on sign convention of power, can we distinguish between convex and convex lens? Yes, definitely. Okay, just imagine. For a convex lens, focal length is positive, right? So if focal length is positive, power is positive. So for a convex lens, focal length is positive, so power will also be positive. So it is a converging lens. Similarly, for a concave lens, focal length is negative, power is negative, so it is a diverging lens. Definitely, you can say that. Okay, because F and P will follow the same sign convention. As simple as that. Clear? Understood? Amazing? Can we move ahead? Okay, so if S is positive, it is converging. If it's negative, it is diverging. Simple. Okay, magnification and image formula or lens formula, same thing. Now you can again try out making the images at different points. You have tried this out in 10th standard, so I'm not going to repeat this again, but I've just put up the table for all of you. You are going to draw this at home. Image at 2f, object at 2f, object beyond 2f, object between f and 2f, then object at f, an object between f and pole. All these variations you try and see where the images form. So both for convex as well as for concave lens. I want you to try this out, okay, for all the different positions and try and see where it comes out to be. Okay, cool. Cool. One last thing before we go to numericals. When you have two lenses in combination, then what you do? You can assume that as one single lens. You can assume that as one single lens, but that one single lens's focal length is given by a formula which looks similar to the equivalent resistance formula of parallel circuits. Remember parallel circuits of resistors, 1 by R1 plus 1 by R2 is 1 by R, same formula for focal lengths. But if you look at it power wise, P effective is actually P1 plus P2. The powers get added, but the focal length reciprocals get added. The lens becomes more powerful when you add one lens over the other lens over the next lens over the next lens. But focal length is reciprocal of that. So 1 by f1 plus 1 by f2 is 1 by f. That's something which you should remember. Okay, that's combination of lenses. Maybe we can solve some questions so that you get an idea. Radius of curvature of a convex surface of a thin plano convex lens is 15 centimeters. Refractive index of its material is 1.6. What do you think is the power of the lens? What do you think is the power of the lens? Come on, my dear students, figure this out. Come on, my dear students, figure this out. What do you think is the answer for this? All right. So radius of curvature of a convex surface of a thin plano convex lens. Plane convex. That's what I need to draw first. Plano convex. Okay. Now, clearly, I know that this will be the ray diagram or almost, and this will meet over here like this. So this is where the focal point is going to be. You can see this is the first surface. It's a plane surface. So R1 will be infinity, everyone. First surface is flat, so infinite. Second surface is curved. So the radius will be this way. It's on this side, which is negative side. Please observe, this is negative, this is positive. So my dear students, what will be R2? Radius of the plano curved surface is 15 centimeters. So this is basically your R2. So R2 will be negative 15 centimeters. Refractive index is 1.6. So mu value is also given to me. 1.6 of course. Question is, what is the power? So to find power, I need focal length. To find focal length, I need to use lens maker formula. So let's use lens maker formula. Lens maker, 1 by f is equal to mu minus 1 by R1 minus 1 by R2. So mu is 1.6 minus 1. R1 is infinity, so 1 by infinity minus 1 by R2 is minus 15. Now 1.6 minus 1 is 0.6 into, what is 1 by a very large number like infinity? 0, right? 1 by a very large number, it will become very small, so it's 0. Minus and minus will just become plus, right? Minus and minus will just become plus, so it will become 1 by 15. Perfect. So 0.6 is nothing but 6 by 10. 0.6 is nothing but 6 by 10, which is also 3 by 5, and into just 1 by 15. This 3 cancels with 15 and it will become 5 times, so it will become 1 by 25. But please keep in mind, everything was in centimeters. So focal length will become 25 centimeters or basically 0.25 meters. But the question is, what is the power of the lens? Power of the lens is 1 by f when f is in meters, so it is 1 by 0.25, so it is basically 4 diopters. So power of the lens is 4 diopters, that too positive. Option D should be correct. Yes, it is. There you go. Sir, use D when f is in centimeters or meters? Only in meters, never in centimeters, Siva. Yeah? Okay, I hope this is clear. Okay, awesome. Gopika, I made my account much after marriage, bacha. Alright, so moving on to the next question coming up on your screen. What is it? Find the magnification of an object of finite width which is placed at 20 centimeters left of a diverging lens of focal length minus 30 centimeters. Of focal length minus 30 centimeters. How could we identify the apt formula for any given question? PS, simple. Solve many questions. That's all. See solved examples. See the lectures online. Look at the solved examples. Solve easiest of the question. Manipulate the formula 100 times. If this is given, then find this. If V is given, find U. If U is given, find F. If F is given, find V. So try different ways. The formula will enter your head. You will know how to use it, when to use it, even if it is twisted, how to use it. After that, you can solve. Okay. So what is the magnification of the object of finite width which is placed at 20 centimeters left of a diverging lens of focal length minus 30 centimeter? Okay. So my dear students, for this, object distance is clearly given. Diverging lens is mentioned. So diverging lens means it is a concave lens. So focal length will be here. Object is placed 20 centimeters. So if this is object and the object is placed at 20 centimeters here, the focal length will be here. So object distance is minus 20 centimeters. Reason being, the rays of light will come like this, right? The rays of light will come like this. This is positive side. This will be your negative side. Positive, negative. Ray of incidence is going that way. Then next thing, your focal length will be negative because it's on the left side. It's minus 30 centimeters. So I think I'm going to use lens formula, which is 1 by V minus 1 by U is equal to 1 by F. Therefore, 1 by V, I don't know. 1 by U, U is minus 20, is equal to 1 by minus 30. Therefore, 1 by V is equal to minus minus plus. Bring it to the other side. It will again become minus. So minus 1 by 30 minus 1 by 20. Okay, solve it further. So it will become 1 by V is equal to, I can take minus sign common. 30 and 20 LCM is 60. 30 goes with 60 2 times. So put 2 plus 20 goes with 60 3 times. So plus 3. So this is 3 plus 2. Minus sign I have just taken it common. So 3 plus 2 is 5. So minus 5 by 60. So which is basically minus 1 by 12. That is 1 by V. So basically V is basically minus 12 centimeters. So I found image distance. Next is find the magnification. I just told you magnification is just V by U. Do not put minus sign. V is minus 12. Object distance is minus 20. So basically divide it 4 times. Minus minus anyways cancels. So this will be 12 divided by 4 is 3. 20 divided by 4 is basically 5. 3 by 5 is nothing but 0.6, right? That's it. 0.6. How many of you got it? Yep, option C. That's the correct answer. That's how you solve the questions. Harini, like I said, 12 marks from this chapter of optical instruments, your reoptics, prisms, dispersion, lenses, reflection, mirrors, all these things. 3 questions related directly or indirectly. So expect that much. Okay, great. Now it's the time for break, because after the break we are going to return for a small topic which is left, and that is prisms. Ready guys? If you want to have dinner also, that's fine. You can quickly grab your dinner and finish it within 10 minutes. I'm just going to set up a countdown timer for just 10 minutes. After 10 minutes, I'm going to meet all of you. And then we'll continue with prisms. Prisms is not going to take much of time. Don't go anywhere. Be back within 10 minutes. Hello dear students, I hope you guys are back and welcome aboard. Hi Siva, yes, 3 hours passed officially, heavy weightage topic. Anush, yes, you can use m is equal to f by f plus u as well, got it. John says, Susanta will cook in 10 minutes and when will you eat, Susanta? Ashrita, optical instruments will be tomorrow, I don't know whether you saw it. Priya Kumari, yes, perfect timing. Just have a look at this particular thing, and by the way, have you not yet smashed the like button? What are you guys doing? Do it right away. So tomorrow optical instruments one shot class, so that will cover magnifying glass, your simple microscope, and on your telescope along with the resolution concept. So all these three major instruments with the resolution will be done tomorrow. So that is tomorrow's class. So let's begin with our class then. Ready guys? Perfect timing. Hello Harni, Ashwita, done. Okay, perfect. Get set, go guys. Call all your friends in case they are gone and thinking that, oh, the lecture is over. No, the lecture is not over. It's yeah, ready. So PS, the timing will be, I think, 5:30 if I'm not wrong. I had put it as 5:30, so it will be at 5:30. Okay, time to start your prisms. Now prisms are fascinating, devices, because you can see a lot of colors coming out of prisms, but those colors come only in a specific way or when you do some specific things. But before that, let's understand what do I mean by a prism. Prism is basically nothing but you see a triangular object that is nothing but a prism made of some translucent material. Now before I go more deep into prisms, let's see, even without knowing too much about prisms or with the basic idea of whatever you have studied, can you answer this? Because this is very closely related to prisms and dispersion phenomena. What will be the color of the sky as seen from the earth if there were no atmosphere? What do you think? Will be again a long lecture? No Siva, it will be just 1 hour 30 minutes max, because optical instruments is a small part. I could not combine it with today's class, so I'm taking it separate. Max to max 1.5 hours. Sir, is this lecture along with questions practice enough? Yes, this lecture along with questions practice, but you also go through NCERT Bacha and refer your notes. That is also very important. Thank you, Kavya, Karthikeyan. D. The session started at 6 o'clock, Bacha. The correct answer is option A, black. Yeah, it will appear to be black, not white, blue or yellow. No. Now, why is it going to be black, you might think, without atmosphere? There is a concept of dispersion plus scattering effect. Both these effects together give you that, color of the sky, and whatever you see. Sometimes during sunset it is orangish, then more yellowish, and then it is blue. Why these colors come? So there is scattering effect and also dispersion effect. We'll talk about it in detail. First of all, this is topic 9.6, okay, of your NCERT. Yes, it is option A, Ashrita. Now prism, like I said, it's a triangular object, translucent material. There are two surfaces, they are called as the refracting faces. This face and this face. If light enters here and exits here, refracting faces, where the refraction occurs. The angle between the refracting faces, is basically called as the refracting angle of the prism, or just the angle of the prism, as simple as that. This is your incident ray, this is your intermediate ray inside the prism, and finally it emerges out. That's why it is also called as the emergent ray. Incident, intermediate or interior ray, and this is the emergent ray. There you will see angle of refraction, refracting angle of the prism or angle of prism. These two are the refracting faces or surfaces of a prism. That's all. Alright, cool. Now let's talk about some important prism angles which you should know. The first thing that you should know, let me just start marking all these angles. Yep. So this angle which the incident ray makes with the normal, that is I1, which the emergent ray makes with the normal is called I2. This is incident angle, this is emergent angle. If this is the arrow marks of the ray, if the arrow mark of the ray is reversed, if I shift it, if I reverse it, then this is how the light ray will go exactly. Then this will become incident ray, incident angle. This will become emergent ray and this will become emergent angle. So they are easily reversible and replaceable with each other. Okay. Next important thing. If it is I1, this angle is, interior angle is R1. This angle of refraction interior is R2. And like I told you before, this angle over here is basically your angle of prism. So I can just call it as A. So A is basically your angle of prism or refracting angle, whatever you want to call it, or refracting angle. Now it is also important to know that this refracting angle is directly related to R1 and R2. It is in fact R1 plus R2. Very, very crucial. This A is R1 plus R2. Important. Another thing, you can also use Snell's law. So using Snell's law, you can easily say sine of I1 by sine of R1, sine I by sine R, is also sine I by sine R, out to in, air to glass, so sine I2 by sine of R2, which is also the refractive index of the prism. So mu is the refractive index of the prism material, which is just by Snell's law, sine of I by sine of R. That's all. Everyone clear till this point? Just put up a thumbs up in the chat box. Okay, cool. A is R1 plus R2. Sin I by sin R, sin I by sin R is refractive index. Now, next thing that you should know is when the ray enters the prism, refracts twice, it goes in a completely different direction as compared to its original direction of travel. Its original direction of travel was here. After refracting twice, it is going here. So it has deviated by some angle. That is angle of deviation. Delta. So that angle of deviation which is produced after refracting twice is given by this formula, I1 plus I2, incident angle plus emergent angle, minus A. This is the formula for angle of deviation. If you know incident and emergent and the angle of prism, that's it, you can find how much the ray has deviated. Important thing to note is that if I1 changes, then even I2 changes. If I change this angle, R1 will change, R2 will change, I2 will change. So changing I1 changes I2. Naturally, if both of them change, even delta will change. So all these quantities are dependent on each other. A is fixed for a given prism. So you might be wondering, is there a graph or is there some kind of a relationship between these angles? The answer is yes. We'll come to that. But before that, let's solve a problem. Like I promised you, I will solve a question on total internal reflection with prisms. So here is the question. It's simple, just geometry, concept of total internal reflection and Snell's law. That's all. At what angle should the ray of light be incident on the face of a prism of refracting angle 75 degree so that it just suffers total internal reflection on the other surface? Refractive index is √2. Let me just show the diagram of what might exactly be happening. So if I show a normal over here, there is total internal reflection happening. That means the ray of light is basically incident at the critical angle. So this IC is basically equal to R2. This is R2, that is equal to IC. This is internal angle. This is basically your 90 degree. So that is gone. That is normal. It is getting totally internally reflected. So total internal reflection is happening at the critical angle. That's what is happening. Next important thing to note, at this point, if I again show a normal, this is basically your R1 and maybe this is your incident light. So this is basically your I1. So now I have visualized the scenario. I think now next thing will be using Snell's law and concept of TIR, total internal reflection. Since the refractive index is given, I can find out IC, standard formula. So the concept of total internal reflection is used. Sine of that critical angle is 1 by refractive index. But like I said, the critical angle is the interior angle, refracting angle R2. So mu is nothing but √2 as per the given question. Whose sine is 1 by √2? Obviously 45. So R2 is basically 45 degrees. So I found out the value of this R2 interior angle. If I know R2, can I find R1? Yes, of course. You might be wondering how. Guys, I just told you this is angle of prism, and this angle of prism is basically R1 plus R2. So angle of prism is clearly given to be 75 degrees, like you can see over here. Refracting angle is given to be 75 degrees. R1 I do not know, but R2 I just figured it out to be 45 degrees. From this, clearly I know the value of R1 is basically 30 degrees. Perfect. Now the last step of the problem. I know R1, I need to find the initial angle of incidence. So I use Snell's law. Use basically Snell's law. See, so many applications are there, step by step, all the formulas, whatever we have learned, we are using it some way or the other. So use it. How? Come on guys. What are you going to do? What are you going to do? Snell's law. So sine of I, sine of R is equal to mu. Sine of I do not know. Sine of R, which is sine of 30 degrees, is mu, which is basically 1 by, oh sorry, not 1 by root 2, it is just root 2. It is just root 2. So basically, sine of I1 will be sine 30 into root 2. Sine 30 is basically half. So this is just going to be 1 by root 2. Whose sine is 1 by root 2, you might ask? Obviously 45 degree. So naturally the value of I1 will be just 45 degree. That is the answer. Angle of incidence is 45 degree. Yes, Anuj, that's the answer. Great, great, great. So we are solving the question, Siva, for the critical incidence. So anything more than this, it will definitely reflect. It starts getting internally reflected at exactly IC. So at angle of, IC, the critical incidence, the TIR effect begins. It starts already. So that is why it is called as a critical angle. Okay. Moving on to the graphical part. Like I told you over here, that if you change I1, I2 changes, delta changes. So can you plot a graph of deviation versus angle of incidence? Yes. The graph looks somewhat like this. Look at it. It looks somewhat like this. These are different angle of incidences. This is the different angles of deviation. It goes down. The deviation decreases as you increase the angle of incidence. It goes down till a minimal point, which is the least deviation, minimum deviation. After a point, it again begins to increase. The deviation, the amount by which the ray deviates, again begins to increase. And this minimum deviation occurs at a very special location. That is when angle of incidence is equal to angle of emergence. Very, very important. So let me just put it up here for all of you. So there is this minimum deviation. So for minimum deviation, the angle of incidence is equal to angle of emergence. In fact, the angle of internal refraction is also the second angle of internal refraction. Okay, both of them are equal. Very, very important. Okay, so this is when minimum deviation occurs, something which you should know. Okay, sir, R1 plus R2 is constant always? Yes. If the prism is the same, Siva, R1 plus R2 will always be constant and it will be equal to A. Perfect. This leads us to another formula, and that formula is given by this. Refractive index can be found if you know what is the least deviation angle. What is the least deviation angle? If you know, you can immediately find it. Sine of A plus least deviation by 2 upon sine of A by 2. So this formula gives you the refractive index of the material. Sine of A plus minimum deviation by 2 upon sine of A by 2. That's the formula. Keep this in mind. Yep. You can also say the refracted ray is parallel to the base. Yep. You can say that. If you want, you can put it up over here. That since the angles are equal, it will look very, very symmetrical. This ray is basically parallel to the base. This is how it will look. Symmetry is there. Symmetry is there. Okay. This ray is parallel to this. Whatever angle it makes here, same angle it makes here. Everything is identical. Incident is equal to emergence. Great. Okay. I have put it up all for all of you. Okay. Just in case if you wanted that. Now, what about the other kind of prism, and that is called as the thin prism. Now in a thin prism, the angle of the prism is very small. That is the meaning of thin prism. A is very, very small. Typically 10 degrees, 5 degrees, 2 degrees, that's all. What happens when the angle is small? The beauty is sine of A will roughly be A in radians. Correct? So everybody knows sine theta is theta, tan theta is theta, cos theta is 1. When theta is very, very small? Very good. Vaishnavi, I have mentioned it on the thumbnail itself. 12 marks. Okay, expected. Most of the times 12 marks. So when that happens, then you don't have to find the deviation by complicated methods. The deviation comes out to be angle of prism into refractive index minus 1. As simple as that. The deviation in case of a thin prism is a very simple formula. It is angle of prism into mu minus 1. You cannot use this for this kind of prism. Thick prism. No. You cannot use it. For thick prism, which formula will you use? This formula. Where did it go? This one. Delta is I1 plus I2 minus A. You have to find I1, you have to find I2, you need to know A. That's the only way you can find the total deviation. Or you can use even this formula if you know refractive index and all of that. But that too, here you get only the least deviation, not any random deviation. Be careful. This is delta M, not any delta. Okay, so be careful. A lot of people use this formula for any random deviation. No, this is only for minimum deviation. Keep this in mind. This formula, which I am showing, is for all the angles, does not matter. This is only for thin prisms though. Okay, keep this in mind. Cool. Let's solve some questions. A ray of light is passing through a thin prism, angle 8 degrees. Find the refractive index of the prism if the angle of deviation is 2 degrees. Okay, everyone should be able to do it. No, it is not minimum deviation, bacha. Although that delta M symbol is put over here, I'll tell you why this need not be delta M. This is not delta M, because what happens is when you draw the graph for a thin prism, delta versus angle of incidence, that graph which was U-shaped becomes roughly like this. So the value of delta minimum or any delta is roughly the same. So here this is I1 is equal to I2, right? It's the same value for almost every angle of incidence. So that's why delta M, delta is roughly the same. For thin prisms, this approximation works. Is that okay, Siva? Good, you asked it. Alright, moving on to this question. Let's see how many of you can do this. Come on, my dear students. A light ray is passing through a thin prism of angle 8 degrees. The refractive index is how much if the deviation is 2. The deviation for a thin prism is angle of prism into mu minus 1. The deviation is given to be 2 degrees. Angle of prism is given to be 8 degrees. Mu is unknown. So this will become 1 by 4. 2 by 8 is 1 by 4 is mu minus 1. So mu will be 1 plus 1 by 4, which is basically 5 by 4. So mu will be basically 1.25. That's the answer. 1.25. Yes, Anush. Okay. Yes. Very good. Very good. Acing, I will give up my promise, but you have to come up in large numbers. It's very demotivating if you show up in such small numbers here. And I will take so much of effort. It's such a big chapter. I'll do current electricity, definitely. And you guys will be like, no sir, I was preparing for boards. Sir, I was doing some other topic. Sir, I forgot. Sir, I did not remember. Sir, I did not have confidence. Then I will feel very bad. So you have to show the strength. Only then I will put in that effort. So I'll be doing current electricity next, by the way. Okay. So 1.25. Yes, that's the correct answer. Perfecto. Amazingo. Let's move on to the next question. The angle of minimum deviation is equal to the angle of prism of an equilateral glass prism. The angle of incidence at which minimum deviation will be obtained is interesting. Come on. Think about this. How are you going to solve this question? The angle of minimum deviation is equal to the angle of prism of an equilateral glass prism. Because it is equilateral, A is basically 60 degrees and the minimum deviation is given to be A. That means that is also 60 degrees. And minimum deviation occurs when I1 is equal to I2. Okay, great. So here is my logic now. Question is the angle of incidence at which minimum deviation is obtained. I know delta is I1 plus I2 minus A. So when delta is minimum, which is 60 degrees, I1 and I2 both are equal. So I1 plus I1 minus A. A is basically 60 degrees. So just put 60 over here. So basically 60 goes over there. It will become 2 into 60 degrees will be 2 times of I1, 2 cancels, so I1 will be 60 degrees again. So the answer is option A. Yes, 60 degrees. Perfecto. 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 Answer is A. Mechanics, Sarvana, I'll be doing after your boards, not before boards, because I'll be doing more of high weightage, important 12th standard first. And I think many topics are being done as we speak. And after that, like modern physics is done, semiconductors, everything is done. So if you do not know where it has been done, please watch the past videos, guys. It's there on our channel itself. So as you go down a little bit, you will see over here. Laws of motion, modern physics completely has been done. Basic maths has been done. Circular motion has been done. There were a few more videos. I don't know why it's not showing over here. I should ask for the playlist. Okay. I've done kinematics 1D and 2D, relative motion as well, in case you have missed that class. I've done mock tests also, and in the previous lessons I have also done sure shot topics which you need for getting 120 plus. So please watch those videos, and even you can watch the live classes which were conducted on this channel. Okay, circular motion, work, power, energy, problem solving, everything has been done, basic maths. So in the days to come I'll be doing more of 12th standard. Okay, fine bacha. Let's move on to the next question, and for that we need the next concept, and that is called as dispersion of light. Okay, now concentrate now, guys. Let's not deviate. Sir, do this, do that. You put it up in the comments, not now. Let's focus on the class. That's not correct, no? You are asking me to do this, that. Focus on the class. Now, see, dispersion means spreading, splitting of colors into constituent wavelengths when it passes through a medium. So what happens is, when light enters any particular medium, the medium has not one refractive index but many refractive indices. Then you might be wondering, sir, when I say refractive index of glass is 1.5, whose refractive index are we exactly talking about? We are talking about the refractive index of yellow color, which is the average color of our big electromagnetic visible spectrum. What you see is a spectrum of colors, right from violet to red, Vib-Gyor, violet, indigo, blue, green, yellow, orange, red, and there are so many intermediate colors in between that, not just these 7 colors. The average color is the yellow color, mean color. So when I give refractive index of different things, of for water, for glass, for diamond, I'm actually giving it for yellow. For red, it is different. For orange, it is different. For blue, it is different. For violet, it is different. For indigo, it is different. So each color has its own refractive index. That means each color will bend differently. Wow. So if each color bends differently, if I take white light, what is white light? White light is perceived by your brain. White is not a true, pure color. It's something which your brain feels to be white. When all the colors, violet, blue, indigo, orange, yellow, all these green, are combined in almost equal proportions, that's what you see as white color. It's a combination of all the colors. Like when you mix colors, same way if you mix colors, you will see it as white. Okay? And there are many experiments to show that as well. When you take a disc made of all the colors and you rotate it very fast, then your brain sees it as white color. Now, in this diagram, think and tell me which ray deviates the most, which ray deviates the least, which color deviates the most, which color deviates the least when passed through a prism. This is white light. Can you see white color? It's splitting into constituent colors. I think violet has deviated the most and red has deviated the least. So guys, can you think and tell me who has the maximum refractive index? No, red is the least, Ashrita, be careful. Red, look at this. Red has deviated only this much. Violet has deviated this much. This was the original intended direction, this and this. Violet is the most, red is the least. So who has the highest refractive index? The one which bent the most, highest refractive index. Red has the least refractive index. Got it? So red has the least refractive index. So yellow is in between red and violet. So here I can put up some important things. Yellow is basically yellow is mean color. Not just that, the refractive index of yellow color is also given to be average of both red and violet. So it is the refractive index of red plus refractive index of violet divided by 2. That is very, very important formula for all of you guys. Please remember this formula. Very, very crucial. Yellow color's refractive index is the average of the extreme two ends of the spectrum's refractive index. Not just that, you can also see the refractive index of yellow is basically less than, more than, and here I can put basically red. It's more than red, definitely. It's more than red, but it is less than violet. It is less than violet. Keep this in mind. Okay, everyone? No problem, Ashrita. Yeah. Okay, so these are standard formulas which you are supposed to know. Now, if I ask you how much did red color deviate, then your answer will be like this. Look at this. Red color's deviation will be angle of prism into refractive index of red minus 1, correct? How much did red color deviate by? Will be nothing but angle of prism into mu r minus 1. Remember thin prism formula which I just showed it to you? Where did it go? Here. A into mu minus 1. So if mu is different, delta will also be different. Great. So if I ask you what is the deviation of the yellow color, you will be like it is angle of prism into mu yellow minus 1. If I ask you what is the deviation of violet color, it will be A into refractive index of violet minus 1. Violet is this one. This is deviation of violet. Okay, this was your original direction of travel. Great. See if you are able to understand it. Yellow will be this much in between them. Is it inversely related to wavelength? No, not exactly inverse. The formula is very different. So we do not have to bother about the formula. It's not inverse. But yeah, it is related oppositely, I would say. If this increases, this decreases, but not exactly inverse. The formula is something weird. Okay. Everybody clear till this point? Put up a thumbs up. Now we define two new parameters. The two new parameters which we define are angular dispersion and dispersive power. What is angular dispersion? You can see the white light split means dispersed into constituent colors. The angle made by the extreme colors red and violet is called as the angle of dispersion. So you can see this is the angle of dispersion and that angle is this angle violet minus your red. Actually I put delta y, or here this should have been delta red, my bad. This should have been delta red. Yeah. Great. Everyone with me? Yeah, these are formulas only applicable for thin prism, which I put obviously because I'm using delta is A into mu minus 1. So this angle is how much the light spreads is violet's deviation minus the red's deviation. So that is your angular dispersion, my dear students. I'm just going to put it up over here. The angular dispersion, generally delta theta is the symbol for it, is nothing but the deviation of violet minus the deviation of red. So when you actually substitute the formulas, which is basically A into mu of violet minus 1 minus A into mu of red minus 1, the final answer that you get is basically A into what do you get over here? A into nothing but mu violet minus mu of red. Just check this out. Why are you getting mu violet minus mu red? Because A into 1 is A. A into 1 is A. A minus A cancels. So A will be common, mu violet minus mu red. That is the final answer for the angular dispersion, something which you should know. Everyone fine till this point? Everyone fine till this point? This is the angular dispersion, how much angle the light spreads by. Similarly, there is another concept which is dispersive power, which is how much dispersion is there per deviation of the average, meaning yellow color. It's the measure of the difference in the refraction of the light of highest and the lowest wavelength that enters per your average deviation. So dispersive power usually has the symbol omega. Okay, this is always per average deviation. Per average deviation, that word is missing. So that is basically delta theta divided by the deviation of yellow color. Meaning what I should put over here is deviation of yellow color. I'll just put it as it is, and this delta theta I can put it as delta violet minus delta red. If I wish to simplify this further, I can do that. How? I will show it to you like this. If I put a bracket minus over here, delta yellow is again delta yellow. What is it? Think about it. It is nothing but a into mu yellow minus 1. Delta yellow is a into mu minus 1, and this I found it out in a simple form to be nothing but mu violet minus your mu red. A cancels. A cancels. So finally my dispersive power comes out to be mu violet minus your mu red divided by your mu yellow minus 1. That's it. That's the formula. Mean or average, same formula? Yes. Mean and average means the same thing. Mean, average, yellow is the same thing. Yellow is the average color for your visible spectrum. Okay, these are standard formulas which you should know. Okay, dispersion angle is how much does the light spread by this angle. Okay, dispersive power is how much it spreads per average color, average color's deviation, which is yellow color. So that's why delta theta by delta yellow. So I put it up beautifully in all the colors so that you will never get confused. In board, I remember studying green instead of yellow. No, it is not green, it is yellow. Yellow is the average color. Okay, so your sun appears to be yellow. Sun is your average color. Okay, that's the most common wavelength. Okay, if a glass prism is dipped in water, what happens to the dispersive power? Come on, let's see how many of you can do this. If you take a glass prism, you see the dispersive power is there. What will happen if you immerse it in water? What do you think? The outside medium has suddenly become more dense. Earlier, the light rays used to bend more because air to glass. Large change in the medium's density. Air to glass, very rare to very dense. Now it is not so rare, dense to little bit more dense. So the deviations will be less, powers will go down. So I think it should be decreases. Correct, Susata. It is decreases. Okay. Siva, that is not there. That formula is present, but it is not there for NEET. It's not there for JEE Advanced also. So don't bother about that formula. Okay. It's not going to come. All right. Great. If you want, you can just do a Google search. Even I will do the same thing and give it to you. Okay. Now, the last part in prism is when you combine the prisms like this. Imagine one prism kept this way. So this prism is spreading the light colors into constituent elements, it's dispersing it. The other prism is exactly opposite and it's combining back all the colors to give back the white light. You will be like, sir, which stupid person will do that? Instead, don't use the prism only, no sir. What mental fellow he is? Why take that white light, spread it like this and again combine it? Are you mental or what? Why you do all this nonsense? There is a beautiful application for this. How many of you know that application is the question? When you use your mobile camera or your big camera or any telescope or even microscope, imagine you are wearing a very colorful dress or you are taking a photograph of a beautiful sunset or scenery, grass is there, mountain is there, sky is there. है ना? Then imagine when the rays of light come, It's not a one color, no? Blue is coming, red is coming, yellow is coming, white is there. So many colors are there. Imagine same lens is there, but each light, because has different wavelength, hence different refractive index, hence different focal length. Different mu, different focal length. Problem. Each color will form an image at different places. Imagine how will the final image look like. Object was one, but the image formed for the same object for different colors was at different places, different sizes. You'll be like, what the hell is this? It will not look good. So what is done is this. They use combination of lenses which look like combination of prisms. So whatever spreading has occurred is countered by another prism so that the final light is maintained, and you will see a clear image. In spite of spreading, it is again countered back by inserting another prism. So there are two combinations. One is called chromatic combination. The second one is called achromatic combination. What is the difference between them? In chromatic combination, there is dispersion, but there is no deviation. Meaning, what happens is that if you have this as one prism, this as another prism, there is dispersion, but there is no deviation. Meaning, if white light was coming like this, it has yellow color also in it. White light has yellow color, meaning because white is made of all the colors: violet, indigo, blue, green, yellow, orange, red, right? Out of that, only look at yellow color for now. It goes like this, it bends, and probably it bends like this, and maybe I should show it in a slightly different way. Just hold on. Okay, so my yellow color out of the white light is coming like this, it's going like that, it goes like this and goes like that. This ray is parallel to this ray. This ray is parallel to this ray. So there is no deviation. This ray and this ray are parallel, so there is no bending, so there is no deviation on an average of an average color. The other colors, we know violet has the highest refractive index, red is the least. So violet color will bend the most. Okay, just hold on. Slightly difficult to draw this diagram, but I'll try my best. Go like this, and probably it will spread like that. Then red color will probably go like this, go like this, like that, and go like this. Do you see that there is an angular spread over here? So there is spread, that means there is dispersion, but there is no deviation. This is one combination. I hope this is clear. PDF is not a public link, Siva, so that's why it's not an AWS link, it is a private link, so that's why it will only come in Telegram. So I can't, even if I pin the link, it is of no use, because it will be only accessible to that account. Okay, so better to join the Telegram. Is that okay, guys? What happened over here? So there is spreading, that means there is dispersion, but there is no deviation. That means the average color did not deviate, it was parallel. That was the first thing. Like a glass slab, yes, you can say that. Other combination is there is a deviation, but there is no dispersion. What is that? Look at this. Actually, this is more like a glass slab. I'll tell you why. Imagine there is a prism, okay, and then you have another prism like this. So the average color came out like this. It bent, went like this, and let's say it went like that. You can see this line is most likely not parallel to this line. Definitely. This line is going this way, this line is going that way. Definitely they are not parallel. But there is no dispersion, meaning, oops, 1 second. What just happened? Okay, so there is no dispersion, meaning the light ray spreads like this, comes like this. This is parallel to the yellow line, and this red line bends bends, and comes like this. All of them are parallel, so there is no angular spread. This is basically deviation is happening, but there is no spreading. Dispersion is not there. Understood, guys? This is more like a glass slab. So in a glass slab, this is exactly what happens. The colors might split, but there is no angular spread, and all the rays are, basically parallel to each other. In a glass slab, apart from this, even this happens. All the rays are also parallel to the original ray. So there is no deviation also, there is no dispersion also in a glass slab. So glass slab is a very special thing. There is no dispersion, there is no deviation. But in this case, one of them is there, one of them is not there. This is there, that is not there. This is there, this is not there. So something or the other. I hope this is clear. Yes, you can join the crash course, bacha. Now, in these cases, like when there is dispersion, but there is no deviation, that means the deviation of yellow color in the first prism is equal to the deviation of the yellow color in the second prism. That is the condition. Whereas in this situation, you will notice this particular relationship holds true. Whatever spread occurs here is the counter spread occurs here. That means the angular spread in the first prism is the angular spread in the second prism. These are the two conditions for both the combinations. When there is no deviation, so you make it no deviation. Whatever yellow color bends, the same amount the yellow color bends in the second prism. When there is no dispersion, no spreading, so whatever spread occurs in the first prism, the same counter spread occurs in the second prism. So they compensate each other. That's all. Okay, so that's something which you should know. Many phenomena which is based on dispersion and scattering and all of that. Just to know, rainbow occurs only because of spreading of light inside a water droplet, and it is combined with total internal reflection, actually speaking. So the rays of light which enters a water drop, if it is white in color, okay, it spreads into multiple colors, violet bending the most, okay, it gets totally internally reflected over here, and basically it comes out like this, and red basically deviates the least. It goes like that, goes like this, and maybe, oops, sorry, it probably goes like this. So you can see the spreading of light occurring inside a prism, inside a water drop, and this dispersion effect leads to the formation of a rainbow. Okay, so that is how a rainbow is exactly formed. Sun is coming, there are water drops, it's raining, and total internal reflection occurs, so you feel that the rainbow is over there. Actually, the rainbow is not an arc, it's a complete circle. You cannot see the lower part because you are on the lower level. If you go high enough, you can probably see the entire circle of the rainbow. Okay, that's how it is. Scattering of light is also very important. When light enters our atmosphere from the sun, this light gets scattered, multiple reflections occur, and each color gets scattered differently. Blue color is scattered the most, red color, wavelength is large, scatters the least. Small wavelengths scatter more, red color passes as it is as much as possible, so it does not scatter so much. So what happens, because the blue color spreads, it's like somebody spreading a paint of blue everywhere on the atmosphere. That's why the sky appears to be blue. That's why the sky appears to be blue in color. Okay, I hope this is clear. So that is basically scattering of light, and that is completely different from dispersion of light. Okay, let's see if we can answer this question. A monochromatic light is passed through a prism. Dash color shows minimum deviation. A light is passed through a prism. Dash color shows the least deviation. Red, violet, yellow or green. Come on, very simple. It's basically violetish only, basically, Siva. So you say that it is the shade of blue. Basically violet, indigo, blue, those are the shades. So it appears bluish or violetish only in color. Okay, come on my dear students. The correct answer is obviously red. Yes, red deviates the least, violet deviates the most. I showed it to you in the diagram also. Next, dispersive power. If the refractive index of the material is mu v is 1.6, mu r is 1.4. What is the dispersive power? Yes, Infernape, Even if you join the crash course after the board exam, you'll get all the lectures. But it is advisable you join it now, because if you can watch few lectures now, no harm. It's not like you are going to lose anything after boards, but why join late than now? Okay, if you can join it now. Okay? Great. So let's see. Dispersive power has a formula of delta violet minus delta red upon delta of yellow minus 1. Delta of violet 1.6. Delta of red 1.4. Delta of yellow, I don't know, minus 1. Oh, but wait a minute, I just told you the formula for delta yellow. Sorry, this was not delta, my bad, I'm so sorry guys. This was mu, I'm so sorry. Ignore, let's start it again. So the formula is mu violet minus mu red upon mu of yellow minus 1. That's the formula for dispersive power. Mu of violet is 1.6, mu of red is 1.4, mu of yellow I don't know, minus 1. Now I have told you the formula of mu yellow. Mu yellow is the average color, so it is mu red plus mu violet divided by 2. So it is basically 1.4 plus 1.6 divided by 2, which is obviously 1.5. So I'm going to put 1.5 over here. Now you can solve the rest. So 1.6 minus 1.4 is basically 0.2. 1.5 minus 1 is 0.5. Basically it is 2 by 5. So where is 2 by 5? I think it is over here as 0.4. 0.4. Yes, option C is the correct answer. Perfect. That's how you solve it. So we have used average colors refractive index formula and also the dispersive power formula. Great. So now you can join the Telegram channel in case you have not joined it, because you're going to get the entire PDF along with the homework question solutions, updates, whatever I'm going to do. And obviously you need to smash the like button, show some love, put up in the comments section, sir, I enjoyed the class. Just put up, if you don't know what to say, just put up a heart or put some emoji. That's the least you can do to show your respect, show your love and show your attendance. Even if you're watching it recorded, no problem. And also put up what do you want next, but most likely I'm going to do current electricity is what I'm thinking. Okay, so I'm so happy that you guys enjoyed, so you learned, and so many things which you would have skipped or probably not revised. Now it's pakka for your boards and pakka for your NEET. So 1 chapter done, 2 chapter done, that's how we are going to progress. Tomorrow at 5:30 I'm going to meet you for your optical instruments. See you. Make sure you join the Telegram channel, smash the like and also hit the subscribe button. This is Captain Shreyas signing off. Hasta la vista. Enjoy dinner. Have a great time. Bye-bye.